Welcome to Katowice, Poland. We are here live attending the United Nations COP24 climate gathering. You are watching the Heartland Institute's Climate Science and Policy Briefing. And the reason we're here is very simple. At COP24 here in Katowice, we have a gathering of the world's global collectivists, the climate totalitarians, the global ruling class elites. And what they want to tell us is that humans are creating a global warming crisis that necessitates people sacrificing affordable energy, people sacrificing abundant energy, and people sacrificing their own individual and national rights to turn over to the global climate bureaucracy. Now here at Katowice, it's a little bit different from recent COP sessions, as they call it, the Conference of the Parties climate meetings. You may recall that some of the recent gathering points have been Paris, Bali, Rio, Montreal, Copenhagen, Marrakesh, Geneva, Milan, Cancun, basically anywhere where you can imagine UN bureaucrats would love to get together on your tax dollar and celebrate how they're telling us how we should live our lives for our own betterment. But here in Katowice, it's different, and it's entirely fitting that this meeting is in Katowice. Katowice is in Poland. This is a mining area, and particularly a coal mining area. This is a place where the economic impacts of restrictions on affordable energy, and particularly fossil fuels, are going to be felt hardest. It's really interesting when you look at the history of Poland. It was 30 years ago, during the 1970s and 1980s, when the Solidarity Labor Union took on the evil, corrupt, communist totalitarians and ultimately prevailed. And now you have that same Solidarity Labor Union that's warning about the impacts on the people here in Poland of the climate agenda from the United Nations. They're taking on a new form of totalitarians. They're taking on climate totalitarians. Solidarity points out that 500,000 jobs in Poland alone rely on the coal sector. These are people that would be put out of work under the UN agenda. Now, the communists or the totalitarians or the communalists, whoever it is, and it varies, it changes from time to time, but the folks that want to restrict individual rights and take away jobs and take away the economic well-being of the people in Poland and everywhere, they're not necessarily coming from Russia, they're coming from the United Nations. UN climate chief Patricia Espinosa says we require deep transformations of our economies and our politics. This is in the name of fighting climate change, transforming economies and politics. The UN Secretary General is now calling populism a threat to the global climate change agenda. And just what is populism? Populism is self-determination, where people, rather than government elites, want to take control of their lives. And now you have the Secretary General of the UN saying that we shouldn't have populism. We shouldn't have individuals looking out for themselves because of the asserted climate crisis. Socialist US politician Bernie Sanders has just tweeted, "It's time for a political revolution." And the motivating factor, of course, is green energy, environmentalism, and the asserted climate crisis. Naomi Klein, who is a writer and a spokesperson for this leftist political movement, has made it abundantly clear. Climate action requires the destruction of capitalism. As she says, we cannot restrict and reduce global carbon dioxide emissions so long as capitalism, in other words, individual economic freedom, exists anywhere in the world. This is the agenda that is being imposed upon us. Václav Klaus, former president of the Czech Republic, former president of the European Union, warned against this. Václav Klaus lived through communist domination of the Czech Republic, back then Czechoslovakia. And he's warned at Heartland climate conferences and elsewhere that the same people, the same agendas that were oppressing Czechoslovakia under communism have now regathered and are using the asserted climate crisis to impose the same so-called solutions and the same agendas. Economic freedom is being challenged just as much by the socialist international green movement than it is under communists back in his day. I mentioned that Solidarity is fighting for the jobs of the Polish people. And the jobs, the economy, and people sometimes will think, well, that's just money, that's greed. But it's important to understand that if you drive up energy prices, if you kill jobs, the real impact, the moral impact it has on human beings and human health and welfare. Energy is the lifeblood of our economy. If you drive up energy prices, you are forcing people to pay much more for the same electricity, the same energy that people use and need every day. What it means is that people have much less money in their budgets for healthcare, for nutrition, for education, for housing, for all the goods and services that make life happier, healthier, longer lasting, and more enjoyable. Affordable energy is indeed a moral issue. Now, if we are to subjugate ourselves to what the United Nations wishes to impose, these climate restrictions, carbon dioxide restrictions, energy restrictions, that will drive up energy prices. And I'll be presenting data on those energy prices later on today. But when you impose expensive, scarce energy on people, what are you doing this for? What are you proposing to do it for? If you're going to take away money from healthcare, from education, et cetera, what's the end game? What we are told is this is necessary to reduce carbon dioxide emissions if you believe in a global warming crisis. But I'll tell you that even if you do believe in a global warming crisis, consider that in the United States, the US, which has been vilified for never joining the Kyoto Protocol, for pulling out of Paris, it's in the United States where this century carbon dioxide emissions are down 15%. In the rest of the world, emissions are up 54%. We're told that we need to abandon our strategy and instead follow what the rest of the world is doing. If you truly believe in a climate crisis, we have scientists here that are going to show that there is no climate crisis. But if you truly believe in that, you should be beating a path to the door of President Donald Trump. You should be looking to emulate what the United States has done, where energy has been affordable and abundant, where carbon dioxide emissions have declined, and where our economy has prospered. This is in strong contrast to the rest of the world. One more note, and a very important note before we get to presentations from the scientists. We're here to unveil, as part of this event, the newest volume in the Climate Change Reconsidered series. The Non-Governmental International Panel on Climate Change, NIPSC as we call it, is a group that's been around publishing comprehensive volumes on the scientific data since 2009. This is the 14th publication from NIPSC. This is approximately 700 pages of comprehensive science, which cites literally thousands of references to the objective data and the peer-reviewed studies. It's been composed by more than 100 scientists who have written or contributed to this volume. And what this particular volume, Climate Change Reconsidered 2, Fossil Fuels, does is it examines the net harms and benefits of fossil fuels. And the evidence is overwhelming. Fossil fuels may be vilified by the left, may be vilified by environmental activists. But when you look at the impact fossil fuels have had on human health and welfare, going back to the dawn of the Industrial Revolution through today, you see that the benefits have far surpassed the costs. And that's going to be the case far into the future as well. So long as fossil fuels, as concentrated energy sources, allow humanity to have access to abundant, affordable energy, fossil fuels as a whole are something we should be celebrating, not vilifying. So we have, for the Non-Governmental International Panel on Climate Change, we have two of our presenters today are people who have been heavily involved in that. The first one is Dennis Avery, who's been a contributing author to NIPSC reports. And the second one I'd like to introduce right now is Dr. Craig Idso. Dr. Idso is chairman of the board for the Center for the Study of Carbon Dioxide and Global Change. As I mentioned, he's been a lead author for Climate Change Reconsidered. He's a PhD scientist. He's somebody that the media doesn't want you to hear of, doesn't want you to know exists, and they don't want you to know about the science that he has performed and reported. So with that, I turn the floor over to Dr. Idso. It's a pleasure to have you.
Thank you, James, and good day to each one of you. It's a pleasure for me to be here. I'd like to thank the Heartland Institute for inviting me to participate in this panel discussion and briefing today. It is safe to say that the debate over the potential impacts and consequences of CO2-induced global warming is very complex. It involves multiple fields of science examining countless aspects of the Earth's atmosphere, land, and ocean systems, as well as the transfer of energy between them and the living biosphere. It should come as no surprise, then, that there are countless ideas, hypotheses, theories, and reports investigating the potential climatic and biological impacts of increasing atmospheric CO2 on these systems. And through all the debate and discussion on the subject, two primary viewpoints have emerged. The first encompasses what is often referred to as climate alarmism. This position is championed by the Intergovernmental Panel on Climate Change, or Ipcc, a political body of the United Nations that is subsequently mirrored by many governments and professional organizations throughout the world. This viewpoint posits that human activities, especially the burning of fossil fuels, are increasing the carbon dioxide content of the atmosphere, which increase, they claim, is leading to potentially catastrophic global warming, producing all sorts of undesirable consequences with little to no positive effects, including more frequent and severe floods and droughts, more numerous and stronger hurricanes, dangerous sea level rise, more frequent and severe storms, increased human mortality, widespread plant and animal extinctions, declining vegetative productivity, deadly coral bleaching, and a decimation of the planet's marine life due to so-called ocean acidification. In contrast, a multitude of climate skeptics disagree with the IPCC's positions, including an international organization of scientists with which I have long been involved, the Non-Governmental International Panel on Climate Change, or NIPSC. Although the NIPSC is willing to concede that humans are indeed causing the CO2 concentration of the atmosphere to rise, it contends heartily against the IPCC's contrary assertions, making the case that many of their conclusions far outstrip or even contradict the implications of a vast array of real-world data that should have informed their predictive models. While other of the IPCC's claims have been reached without consideration of important scientific studies, of which its authors were apparently unaware. This latter point is important because the IPCC claims to have based its assessments on the best available science, and that they have examined all pertinent literature in reaching their conclusions. Well, most certainly they have not. On topics from aerosols to zooxanthellae and everything else in between, the NIPSC has reviewed numerous of these neglected papers, which come from a broad spectrum of the peer-reviewed scientific literature. And it arrives at conclusions that are either much less ominous in their negative implications or actually positive in nature, detailing its findings in several independent reports that have been published over the past several years. I have had the opportunity to act as a lead editor or author in each of the preceding NIPSC volumes. Given what is compiled in those reports and the thousands of peer-reviewed scientific references therein, I can tell you with complete confidence that there is absolutely no observational evidence that provides any compelling support for the contention that there is something unusual, unnatural, or unprecedented about Earth's current warmth. Neither are there any real-world data that confirm that floods, droughts, wildfires, or hurricanes are becoming either more frequent or more severe as a result of global warming. Nor is there any indication that the total mass of Earth's polar ice sheets is on the verge of declining any faster than the proverbial snail's pace at which it has done so in the recent past. Nor is there any reason to believe that sea levels are about to rise precipitously and inundate the world's coastal lowlands. Likewise, there is no evidence to support the claims that searing heat waves are killing the poor and elderly and drying up precious farmland, that devastating diseases are spreading to regions previously considered immune to them, that migrating plants and animals will be unable to move to cooler locations fast enough to avoid extinction, that coral reefs will dissolve into oblivion as the oceans warm and turn acidic, or that anarchy will spread within and among nations as fighting erupts over dwindling water and food supplies. Unfortunately, there is not enough time in my presentation today to give adequate discussion to each of these topics, and therefore I will only focus on two of them: the IPCC-based contention that the increasing carbon dioxide concentration of the atmosphere is causing dangerous global warming, and that warming is decimating the living biosphere. Information on other topics in the climate change debate can be accessed via the website climatechangereconsidered.org, where you can further learn about the many differences that exist between the NIPSC and IPCC positions, by reading each of the Ipcc reports posted there. Turning our focus now to the Ipcc, it is their position that Earth's rising atmospheric CO2 concentration is causing dangerous global warming. Proof of this claim, they contend, is found in climate model projections of past and future temperatures, as well as in historic near-surface air temperature records of the past century or so. The latter of which records they say have reached magnitudes that are unprecedented over the past 2 millennia or more. The non-governmental International Panel on Climate Change, on the other hand, after examining numerous research articles referenced and not referenced by the Ipcc, has reached an opposite conclusion, finding there is nothing unique, unusual, or unnatural about the recent warming of the Earth, which it contends is nothing more than a manifestation of a recurrence of natural cyclical phenomena that produced the higher temperatures of similar past warm periods. The present run-of-the-mill warming, which began around 1860, is thus viewed as a garden variety climate change of the type that has occurred over and over again for the past several hundreds of thousands of years without any help from humanity. One of the key evidences utilized by the Ipcc in reaching this conclusion comes from comparing the observed pattern of Earth's late 20th century warming against that calculated by climate models. According to the Ipcc's model-based theory, greenhouse gas warming presents a unique fingerprint in the form of a warming trend that increases with altitude in the tropical troposphere, as shown by the red and orange colors presented in the center of this figure and outlined in blue. Climate changes due to solar variability or other known natural factors do not yield this pattern. However, as shown in this next slide, real-world observations do not match this model-expected theory. Each of the red bars on this graphic shows warming that should have occurred in the tropical upper troposphere over the period 1979 to 2017, as predicted by simulations from 102 different climate models. The average predicted warming rate over this nearly 4-decade-long period, as shown by the black horizontal dashed line, is 0.44 degrees Celsius per decade. In contrast, satellite measurements, shown in blue, reveal that the actual warming rate is 3 times smaller than that predicted by the models. This divergence between model projections and observational data is even more evident in this next figure, which plots both predicted and observed temperature anomalies of the upper tropical troposphere. Once again, observational data reveal that the model-derived temperature projections are running far too hot. So much so, in fact, that mathematical analyses confirm a statistically significant difference between the two temperature series. This key fact alone is sufficient to provide more than enough of a basis for invalidating all of these climate models. Other key data that falsify the Ipcc narrative that rising atmospheric CO2 concentrations are causing dangerous global warming are evidenced in long-term geologic reconstructions of these two parameters. Multiple studies, for example, show a decoupling between temperature and atmospheric CO2 in their records, revealing times when CO2 rises and temperatures fall, times when CO2 falls and temperatures rise, or still other times when a change in either of these two parameters evokes no change in the other. If CO2 was the all-important driver of temperature that the Ipcc makes it out to be, such observations would not exist. Additional red flags in the CO2 temperature relationship are also noted in the ice core records of the more recent past, which reveal that the peak warmth of the preceding 4 interglacial periods was between 1 and 2 degrees Celsius higher than that observed during the current interglacial in which we now live, despite there being 45% more CO2 in the atmosphere presently. Additional proxy data records show that current global temperatures are about the same level of warmth or slightly cooler than that experienced approximately 1,000 years ago during the multi-century long medieval warm period, as well as during the Roman warm period that occurred 1,000 years before that. Such warmth, which has naturally occurred over regular intervals and at much smaller atmospheric CO2 concentrations than today, further strengthens the notion that there is nothing unusual, unnatural, or unprecedented about the current warm period, and that the current warm period is only minimally affected, if at all, by the modern increase in atmospheric CO2. Another problematic issue with the IPCC's thesis is the recent global warming pause, or temperature hiatus. Despite an 11% increase in atmospheric CO2 over the past 2 decades, which increase represents fully 1/4 of the total increase in CO2 during the modern era, global temperatures have shown little, if any, warming. Not surprisingly, not one of the climate models predicted this temperature plateau. They all failed to see it coming. Now, considering these several evidences, it is truly disingenuous of the IPCC to claim with any degree of certitude that the modern temperature increase bears an anthropogenic fingerprint, or that rising atmospheric CO2 is causing dangerous global warming. There exists far too much data to the contrary. And because the models all fail in this regard, the global warming debate should really end right here. For pretty much all of the additional ancillary climate-related projections of the IPCC rely on the unrealistic temperature rise predicted by these now invalidated climate models. Nevertheless, we shall briefly examine one of these key ancillary projections, evaluating how it compares with real-world data. It is no secret that the IPCC predicts CO2-induced global warming will exact a heavy toll on Earth's living biosphere. Warmer temperatures, searing heat waves, intense and longer-lasting drought, and other climate-related disruptions are all expected to negatively impact plant growth and food yields, wreaking havoc all along the food chain, while also driving large percentages of plant and animal species towards extinction. In contrast, the Ipcc envisions a future in which there will be a great CO2-induced stimulation of vegetative productivity, resulting in ecosystem stability and proliferation, as opposed to extinction. And there is much evidence from the peer-reviewed scientific literature to support this latter view. The favorable outcome anticipated by the Ipcc is rooted in the fact that carbon dioxide is the primary raw material utilized by plants during the process of photosynthesis to build and construct their tissues. Think of it as the food that sustains essentially all plants on the face of the earth. And fortunately, the more CO2 plants eat or take in from the air, the bigger and better they grow. Consequently, plant growth is near universally enhanced at higher atmospheric CO2 concentrations, which fact has been demonstrated in observations from literally thousands of laboratory and field experiments conducted over the past 5 decades. Typically, a 300 part per million increase in the air's CO2 content raises the productivity of most plants by about 1/3 to 1/2, which stimulation is generally manifested by an increase in the number of branches and tillers, more and thicker leaves, more extensive root systems, and more flowers and fruit. In addition to inducing such amazing productivity benefits, rising atmospheric CO2 also confers upon plants other important advantages. It increases their water use efficiency and helps them better cope with low levels of essential resources, such as light, water, and nutrients, as well as to endure environmental stresses such as soil salinity, high temperatures, and air pollution. Consequently, in light of the plant productivity gains that result from the aerial fertilization effect of the ongoing rise in atmospheric CO2, plus its transpiration reducing effect that boosts plant water use efficiency, along with its stress alleviating effect that lessens the negative growth impacts of resource limitations and environmental constraints, the world's vegetation possesses an ideal mix of abilities to reap tremendous growth in the years and decades to come. And based on a multitude of real-world observations, that future is now, as evidence from all across the globe indicates that the terrestrial biosphere is already experiencing an incredible stimulation of growth, due in large measure to the approximate 45% increase in atmospheric CO2 that has occurred since the beginning of the Industrial Revolution. Consider, for example, this next figure, which shows that prior to around 1940, Earth's land surfaces were a net source of CO2 carbon to the atmosphere. From 1940 onward, however, the terrestrial biosphere has become, in the mean, an increasingly greater sink for CO2 carbon. This fact is further borne out in another study examining the sources and sinks of CO2, and which includes data for both the land and ocean. As seen here, the global carbon uptake has actually doubled over the past half century from 2.4 to 5 billion tons per year. Additional evidence for this great greening of the Earth, as it is often called, is seen in satellite-derived data. But what is most surprising about these observations is the fact that they are even occurring at all. That is, if you accept the claims of the climate alarmists. Consider, for example, their concerns that since 1980, the Earth has weathered 3, and almost 4 now, of the warmest decades in the modern temperature instrumental record, as well as a handful of intense and persistent El Niño events, large-scale deforestation, unprecedented forest fires, and episodes of persistent, widespread, and severe drought. At the same time, the air's CO2 content has increased by more than 16%, and the human population has grown by over 55%. To global warming alarmists, the Earth has been in the throes of a veritable climate change Armageddon. So just how bad has the terrestrial biosphere suffered in response to these much-feared events? To answer frankly, not at all. Increasing levels of atmospheric CO2 have actually helped to overpower these and other growth-inhibiting influences in all but a few locales. Such was the conclusion of a team of researchers who analyzed long-term satellite-derived leaf area index records, together with the output of 10 global ecosystem models for the period 1982 to 2009. The results of their analysis revealed a persistent and widespread greening of the globe's vegetated area, evidenced by the green, blue, and violet shading in this figure. Further analyses revealed that CO2 fertilization effects explained 70% of the observed greening trend, followed by nitrogen deposition at 9%, climate change at 8%, and land cover change at 4%. Similar results were reported last year by another research team. Working with over 2,100 globally distributed databases, they analyzed the spatial temporal patterns of net primary production over the past half century, which patterns are illustrated in this figure. Their results indicated that for the planet as a whole, net primary production increased significantly by 21.5% over the past 5 decades. Not surprisingly, the authors report that atmospheric CO2 concentration was the dominant factor controlling the interannual variability and increase of global net primary production over the period of study. This next slide shows the results of a third independent group of scientists who have further documented the growth-enhancing impacts of rising atmospheric CO2 on the biosphere. Once again, as shown by the overwhelming presence of blue shading in this figure, despite the many real and imagined threats and assaults on vegetation by humanity and nature alike, the terrestrial biosphere has met and overcome these challenges. In this instance, increasing its gross primary production by 24.9 petagrams of carbon over the past 3 decades. And once again, rising atmospheric CO2 concentrations were found to be the principal cause of this increase, with the authors determining that a 10% increase in atmospheric CO2 induces an approximate 8% increase in global gross primary production. And one final example highlighting the positive impacts of atmospheric CO2 enrichment that are sweeping across the planet, A group of 7 scientists employed a series of global data sets earlier this year in an effort to estimate global monthly gross primary productivity over the period 1982 to 2015. Their results are highlighted in this figure. As indicated by the spatial distribution of the linear trends in gross primary productivity, linear trends in gross primary productivity is overwhelmingly positive, demonstrating that a large and significant vegetative enhancement has occurred in over 75% of the land area over the past 34 years. With respect to the factors responsible for these trends, the researchers analyzed 5 potential influences, including land cover change, rising atmospheric CO2 concentrations, and changes in solar radiation, temperature, and soil water status. Their results indicated that increases in atmospheric CO2 accounted for the largest contribution to the globally average gross primary productivity trends, accounting for 65.73%, which percentage is more than 5 times the value of the next most significant contributing factor of temperature. Now, in considering these several findings I've just presented, it is quite clear that the Ipcc's model-based projections of the consequences of rising atmospheric CO2 are way off the mark. Dangerous CO2-induced global warming is not presently occurring, nor will it likely ever occur in the future. Likewise, pessimistic forecasts of ecosystem degradation and collapse fail to match observed trends showing widespread enhancement of planetary vegetation. These and other phantom pillars that form the foundation of the Ipcc reports are merely the conceptual constructs of woefully inadequate climate models used to achieve a political end. Real-world observational data, in contrast, do not support a catastrophic or even problematic view of global warming. Yet despite these facts and many others that show rising atmospheric CO2 to be a non-problem, delegates from numerous governments of the world are today gathered here in Poland for the United Nations COP24 summit and are using fear of a concocted climate crisis to prod the citizens of their respective countries to do what no one in their right mind would otherwise even contemplate doing, and that is to regulate CO2 emissions by scaling back and largely eliminating humanity's use of fossil fuels. The pursuit of such a course of action is almost unbelievable, given the harm it would inflict on the world economy, let alone given the weight of scientific observations disproving the Ipcc narrative. Hoping to interject some sense of sanity into this surreal situation, the non-governmental International Panel on Climate Change is once again pushing back against the outlandish and idiotic course of action proposed by the Ipcc. And it is doing so via the release of its latest tome, Climate Change Reconsidered 2: Fossil Fuels. Comprising the work of over 100 scientists, economists, and other experts, the new 8-chapter volume assesses the costs and benefits of fossil fuels, once again highlighting research that is overlooked or ignored by the Ipcc. Not surprisingly, the work refutes the Ipcc's notion that future impacts of climate change on humanity and the environment justify dramatic reductions in fossil fuel use. As one of the lead authors of this newest volume in the Climate Change Reconsidered series, I would like to formally introduce this database masterpiece to you by briefly highlighting the content presented in each of its chapters. The foundation of the cost-benefit analysis is laid in the book's first 2 chapters. Chapter 1 describes how economic principles can be applied to environmental issues, and it presents a good overview of how economists approach the global warming debate. Chapter 2 briefly reviews and updates the climate science addressed in previous Climate Change Reconsidered volumes, confirming that the Ipcc continues to exaggerate the amount of warming likely to occur if atmospheric CO2 concentrations continue to rise, as well as the projected impacts of such warming on the global environment and human well-being. Much of the preceding material in my talk is based upon material from this chapter. The beneficial impacts of fossil fuels on human prosperity, human health, and the environment are discussed in chapters 3, 4, and 5. The Ipcc downplays or omits recognition of many of these benefits, which undercuts their ability to perform a valid assessment of the impacts resulting from the implementation of policies that reduce fossil fuel use. The use of coal in electric power generation in the United States alone, for example, has an existence value of approximately $1.3 trillion and supports nearly 7 million jobs. Yet the IPCC gives little thought as to the full positive impacts this industry presently has on the global economy, or the negative impacts its proposed fossil fuel reducing policies would inflict upon it. Another key benefit the IPCC ignores is the direct monetary impact of rising atmospheric CO2 concentrations on world food production, which is calculated to have added $3.2 trillion to the economy over the past 50-some years, and will yet add another $10 trillion by around the year 2050. It also fails to acknowledge the benefits that are resulting from the great greening of the earth spoken about earlier in my talk, benefits that impact humanity and nature alike. Neither does the IPCC recognize the indirect contributions fossil fuels have made on improving crop yields, which have further helped to increase food production to levels necessary to feed a global population of over 7 billion people, without causing massive deforestation or excessive usurpation of land from wild nature to meet those needs. Fossil fuels are also largely responsible for driving prosperity that has led to improvements in human nutrition, housing, and working conditions, as well as cleaner air and water, all of which factors have contributed to the dramatic improvements observed in human longevity and the decline in the incidence of diseases and premature deaths of the modern era. The marginally warmer temperatures observed in some parts of the world at the end of the 20th and beginning of the 21st centuries have further contributed to human health by preventing millions of premature deaths from illnesses or health effects related to colder temperatures. A true accounting of the costs and benefits of ending humanity's reliance on fossil fuels certainly must include the opportunity cost of foregoing these benefits. Chapters 6 and 7 present an accurate accounting of the biggest alleged social costs of fossil fuels, those attributable to chemical compounds released during their combustion of fossil fuels, as well as to what the IPCC calls threats to human security, which includes famine, conflict, damage from floods and extreme weather, and forced migration. The Ipcc finds these costs to be greatly exaggerated, unsupported by real observational data and credible economic, scientific, and public health research. When these major sources of concern are addressed, any remaining costs are quite small or speculative. Chapter 8, the final chapter of the book, culminates the work of the preceding chapters by conducting a cost-benefit analysis. At the risk of overly simplifying what is a very complicated analysis, the conclusions of that chapter affirm 1, the net benefits of fossil fuels, 2, the small and highly uncertain cost of man-made climate change, and 3, the very high cost of regulations aimed at reducing greenhouse gas emissions relative to the benefits they produce. In concluding my presentation today, I would like to remind each of us that at its creation, the IPCC was charged with a mandate to, quote, make policy relevant as opposed to policy prescriptive assessments of the existing worldwide literature on the scientific, technical, and socioeconomic aspects of climate change, end quote. In doing so, the IPCC has claimed that its work comprises, quote, the most comprehensive and up-to-date reports available on the subject, and constitutes the standard reference for all concerned with climate change in academia, government, and industry worldwide, end quote. However, as evidenced by the material presented in the current and preceding Ipcc volumes, as well as in my talk here today, it is clear that the IPCC has failed in its purpose. Although the IPCC claims to be unbiased and have based its assessment on the best available science, such is not the case. In many instances, conclusions have been seriously exaggerated, relevant facts have been distorted, and key scientific studies have been omitted or ignored, particularly so with respect to performing a proper evaluation on the costs and benefits of fossil fuel use. Literally thousands of peer-reviewed scientific journal articles do not support a catastrophic or even problematic view of global warming. Yet climate alarmism has become the modus operandi of the Ipcc. This fact is most unfortunate because in compiling their reports, the Ipcc was either purposely blind to views that ran counter to the materials they utilized, or its authors did not invest the amount of time, energy, and resources needed to fully investigate an issue that has profound significance for society. If the former view is correct, then such actions amount to scientific manipulation and fraud. Well, if the latter view is correct, the Ipcc is guilty of gross incompetence. Whatever the case, it seems pretty obvious that the Ipcc has outlived its usefulness, having been co-opted by those with little regard for expressing the full truth. Hopefully, policy leaders will wise up to these facts and save themselves from implementing legislation that will do far more harm to their constituents than good. Thank you.
Thank you for that outstanding presentation, Dr. Ridso. I'll note for those of you watching on the live stream that we are planning a panel discussion at the end of these few presentations, and I will be asking questions of the panelists. We'll have some interactive discussion, and also on the live stream on our YouTube page as well. If you have questions or comments, please post them there. Our communications director, Jim Lakely, as well as Keely Drukala of the Heartland Institute are monitoring that, and I would be happy to ask any of those questions as well. So let your curiosity flow and don't be shy. In the meantime, I'd like to introduce our next speaker. Our next speaker is Dennis Avery. Dennis is the director of the Center for Global Food Issues at the Hudson Institute. He has also served in the U.S. Department of Agriculture and the U.S. Department of State. He has served as a contributing author for Climate Change Reconsidered. Dennis is a co-author of the landmark book, Global Warming Every 1,500 Years, and he is also somebody who is an expert on climate change and food production. So with that, I'd like to introduce Dennis Avery.
Thank you, James, for the kind introduction, and my thanks to the Heartland Institute for making my appearance here possible. I've just come from the COP24 meeting, where the most sacred word seems to be sustainability. And I'm going to talk today about sustainability because the people at COP24 don't think we are very sustainable. In fact, if you look at history, the average human society has lasted only about 400 years. The long-lived champions of past societies, the Romans and the Mayans, lasted only 800 years. Since Thomas Malthus in 1798, historians have told us this unsustainability goes back to having too many children. Humans are oversexed, and we inevitably overwhelm the natural resources of our cultures and our places on the earth with overpopulation. But modern archaeology disagrees. They say the problem was not overpopulation. The problem was that every so often, Mother Nature inflicted a little ice age on this planet, and that gave us colder, shorter, cloudier growing seasons with massive changes in regional rainfall patterns and centuries-long droughts that afflicted most of the Eurasian steppes, the whole Mediterranean basin, the American Southwest, large tracts of Central and Latin America, and massive parts of China. Our cultures in the past failed because they couldn't feed their cities when the production from their fields was slashed by inopportune weather by 20 to 80%. The key to this is what I call the Dansgaard-Oeschger cycle. It's the subject of the book that I wrote with Fred Singer, Unstoppable Global Warming Every 1,500 Years. And it's painful to point out that the Earth has given us weather as good as we're enjoying today, including the extremes, about 10 to 15% of the last 200,000 years. We've had two 90,000-year ice ages, and the other 30,000 years have been split half and half between warmings like this, warm, stable, good crops, and climate chaos. Climate chaos in the little ice ages. Colder, less stable. Storms, Noah's floods, centuries in which Europe, for example, could hardly harvest a grain crop because of the incessant rain. That was northern Europe, of course, and in southern Europe, it was too dry to grow anything. Human numbers shrank. And what we've found from the new archaeology with its broader scope and its more precise dating is that we had population surges in the Earth's past. They occurred during the global warmings when the crops were good. That should be no surprise to anybody. And after we got this larger population and supported it successfully for centuries at a time, suddenly nature turned against our farmers. They couldn't feed the cities. Often the farmers themselves couldn't find enough to survive eating. Egypt has a number of past cold centuries in which the Nile floods failed so consistently that parents were recorded by writers at the time of eating their own children. That's about as stark as it gets. And I think their reasoning went that the gods had taken away their food, and so they would eat their children in hopes of surviving long enough that the gods would bring back the food and they could have more children. Desperation yields desperate results. Today, we've farmed beyond that vulnerability. We have improved our agriculture to the point where we could now almost certainly feed the population the Earth will have in the next little ice age from the farming resources and farming systems that we have today. And I want to talk about how we got to that point. My guru in all of this is an archaeologist called David Zhang. He's Chinese. He serves at the University of Hong Kong. And he's written the most comprehensive study of the collapses in our past societies. His conclusion is that 90% of them died during little ice ages. The exceptions were primarily in the medieval warming, when most of Eurasia was conquered by the Muslim horde, the Mongol horde. And the Mongols were attacking because the weather was so good and their livestock had multiplied so beautifully, and so many more children had been born and grown, and they needed elbow room, as Adolf Hitler would have put it. People in the past spaced their births. At times, they put infants, newborn infants, out on the hills and let whatever would happen to them happen. At times, they forced the elderly out into the winter cold. This was all too common, for example, among the Inuit in the Arctic. Those could achieve only modest changes in population size. A 50-80% fall in food supplies couldn't be handled. Mesopotamia, for example, at 2200 BC, the first aspect of a little ice age that extended from Turkey clear down through Ethiopia was a 300-year drought. Covered the whole region. No way to walk off. You were doomed by Mother Nature. Mother Nature may know best, but she certainly doesn't care. She doesn't give a thin damn about humans or their livestock or their crops or their dreams for the future or their achievement to date of finding a dangerous world and making it safer. We didn't find a safe world and make it dangerous. The key to this achievement by humans from the past is called collective learning. And it arose fundamentally from our language skills and our ability to convey meaning to each other and to interact and to conflate the whole set of ideas that came forward into something better than we'd had before. And I can tell you for a fact, based on the recent studies from Cambridge University, that it goes at least as far back as the 50,000 years when we got the last glacial maximum. Temperatures frequently as low as minus 50 degrees Celsius and Fahrenheit. The Neanderthals were in Europe. They'd been living in caves for many centuries, hunting in the forests. But all the grass and trees disappeared in the cold and the drought. And they could still live in the caves and protect themselves from predators with a fire at the mouth of the cave. But suddenly the mastodons and the mammoths they hunted had walked off because tundra isn't as nutritious as grass, and so the animals were migrating like today's Arctic caribou. There's no record of any combat between the Neanderthals and the other peoples of Europe. They just disappeared. The people who have predominated since the last glacial maximum in the European DNA were called Gravettians. They were nomads from the steppes in the Black Sea area. They'd never had wood or caves. They had learned to sew mammoth skin tents, some big enough to hold 50 people, held up by salvaged mammoth ribs, again, no trees to make a bow that would hold up the tent. And they used these tents to follow the herds. And hunting such large animals, they had developed something that the technologists call an Atlatl. It's basically a spear thrower. It's an extension of the human arm, and you learn to throw your spear farther than you could throw it without the spear thrower, and so remain safe when that spear hits the mammoth and the mammoth starts to freak out. Technology. Fairly simple, massively useful. Tents, tent poles in the form of mastodon tusks or mammoth ribs. And perhaps most clever of all, they bred wolves into dogs because they had these huge herds of animals roaming on the vast wastelands of a drought-stricken tundra. They needed to find those animals, and while they were following the animals, they needed some way to protect their camps at night. The wolves were there to get the bones, the mammoth bones, and crunch them to get at the rich mineral interior. And that gave the nomads a set of wolves with which to work. And they gradually got the wolves to come closer and closer to the village, or to the tents, to the camp. And then they made friends with the pups, and they decided which pups should be left alive to mature and which were too aggressive and should be sacrificed. And over 40,000 years, man's best friend, man's most useful animal relationship came into being. Farming, of course, makes cities possible. Stone Age man could feed about 2 people per square mile. Slash and burn farming can feed about 60 per square mile. But today humans are sustainably and consistently feeding 245 people per square mile, and the average is still rising. And some of it, of course, has to do with what Craig Yudso just told us about the enrichment of the air with additional CO2, the plant food and the water enhancing factor that has done so much for us already and promises to do more. Originally, we scattered a few seeds on the riverbank and watched the plants grow and harvested the seeds and kept what we thought were the best of the seeds to replant for the next year. And we put them carefully aside in a basket or a bowl. And for year after year after year, we gradually expanded the number of seeds we grew, the number of seeds we saved, the number of acres we could plant with those seeds. We got so much food that not only could we feed ourselves, but we could bait the grazing animals in our region with grain to keep them near to where we were living. They weren't domesticated animals, but they were available for hunting to a much greater extent than if we were just wandering the wilderness. And then some of the favored rivers in the world had annual floods. And in those rivers, mankind achieved its first urban takeoff. Tigris and Euphrates Valley in Mesopotamia, the Nile Valley in Egypt, the Indus Valley in India, the Yellow River, not the Yangtze River in China originally, because the Yangtze River was still flowing and flooding too ardently. They were growing millet in the Yellow River. And that was the cradle of Chinese civilization. And all of these favored rivers gave us a taste of what humanity could become if we didn't have to wander the countryside with a bow and an arrow and a baby on our backs. We were able to become sedentary. We were able to have homes. We were able to store things. We were able to sit around village fires. We could conduct religious ceremonies. The local priest, if you will, became a specialist in healing and in raising our hopes. And other people stopped becoming farmers and became traders and carried what we had in surplus to trade with another tribe for what they had in surplus. And that too is one of the first building blocks of civilization. And about 6,000 years ago, the temple sites became towns because we could feed enough people who could carry their weight, earn their worth in the town rather than farming. And the larger the town, the better the farming got, the larger the towns grew, the more sophisticated the society, the more of a hierarchy developed. And all of that hierarchy was focused on making sure that their people did well, that their people did at least as well as the people up and down the river or on the other side of the mountain. Romans were the most famous collapse of all. There are over 200 reasons offered why Rome collapsed. None of them seem very persuasive, and I'll talk today about what I describe in my new book, Climates of Collapse, Why Our Past Cultures Failed. What really happened to Rome? The Romans, about 128 BC, had just conquered the Carthaginians who lived in North Africa, right near the Straits of Gibraltar. And the Romans spread Carthage with salt so that it would never grow anything again. And they looked at this land they had not really looked at before, and they said, we think there's enough rainfall here to irrigate grain. We have these clever engineers. We have all of these urban skills. And they irrigated grain in North Africa for the next 800 years. What they didn't know is that there hadn't been that much rain in North Africa previously. That rain had been in Central Africa, nourishing yam growers and hunters in East and West Africa, Kenya, Tanzania, so forth. But nature, in her wisdom, had melted the Arctic ice and pulled the rain up from Central Africa to North Africa, and the Romans saw it and took advantage and became the greatest empire of the ancient world. More than 1 million people fed, according to Roman writers, for 8 months of the year from North Africa and for 4 months of the year from the Nile Valley of Egypt. And they did it with trade. But they also built a fabulous set of cities in North Africa during those 800 years. You can go there today to a small Arab village which has its own 60,000-seat Colosseum for Roman games. Colosseum is still there. The people who filled the seats long since disappeared. They disappeared at 600 BC because the climate changed. It changed against the Romans. It changed against the nomadic herders of the Eurasian steppes. These were people who never had settled lands. They had grazing rights that were defended with swords, bows, and arrows. And once they learned to ride the horses they'd been keeping for milk, they loved mare's milk fermented. They started riding those horses, and they became the fiercest warriors in the world, and they were unstoppable for about 6,000 years. Not until the machine gun was invented for World War I would anybody have been able to successfully stave off dedicated nomad herders on the warpath. They displaced huge numbers of people when they had a drought in what had been their homelands. They invaded what had been better watered people in the Little Ice Ages. The Celts, for example, started in the lower Danube Valley and wound up clinging by their fingernails to the shores of the Atlantic Ocean in Ireland and Scotland. They had been bumped west through Germany, through France, through Normandy, through Britain. China was so afflicted by nomads that they built the Great Wall. And the Great Wall worked as long as they kept it manned. But when things were good and the economy was perking along and the crops were abundant, they sometimes forgot that they needed to be careful about the people north of the Great Wall. And in the 12th century, as I mentioned, the Mongol horde became so abundant and so ferocious that they invaded all their neighbors in all directions. And because it was a little ice age, everybody's crops were abundant, and they could be successfully governed by Mongols who were not really part of the culture, but had the Mongol horde in the background as a peace force. And for nearly 200 years, the Mongols made the empires of the past look puny. And then came the Little Ice Age, and the floods and the droughts returned, and the crops failed, and the people starved and took to the roads, and the world became ungovernable again. Mayans. I submit the Mayans were cleverer than the Romans. They lasted just as long. They grew a larger population. And they committed none of the environmental sins of which they have been accused. We have been told that they succumbed to massive soil erosion because we today looked at the steep limestone hills and swamps of Central America and said, there's no way to support a lot of people here. Can't be done. The limestone, yeah, you got a lot of rain during the heavy rainy season, but the limestone lets it quickly seep away, and if they have to dig for it, some of their cenotes had to be dug down 80, 100 feet to get water. How in the world? We assume that they did some form of slash and burn farming, and accurate archaeologists now tell us that's true. They started with slash and burn. And the sediment cores go down today to the years when the Mayans were first starting out and the soil erosion was massive. They realized they had to do better. So they started building stone terraces. And they built thousands of miles of stone terrace to favor their crop production. But the rains in the heavy rainy season were so heavy that the rocks kept washing out. And then they discovered the secret. The Mayans became swamp farmers. They would build their cities halfway down a long slope, and they would give it lots of nice, bright cement streets and plazas, lots of room for recreation and religious ceremonies and gatherings of the people. But each of these cement surfaces was cleverly slanted toward the mouth of the reservoir. And they built each city a series of big reservoirs, which they carefully tended, one of them for city use, one of them for religious ceremonies, and one for trickling a little bit of water all dry season long down into the swamp below. And they created raised bed cropping services, which are famous today. They were invented by the Mayans, used later by the people at Mexico City. And the crop production year-round on those raised bed cropping beds was more sustainable than flowing rivers in Central America. There were decades-long droughts before the Mayans collapsed. And in those decades-long droughts, the cities on rivers failed. The swamp farming sustained itself and sustained the people. And recently they did a LIDAR survey of the lowlands in Guatemala. Laser assessment of what's under the jungle. They found 60,000 Mayan structures in a brief survey. They've had to double their estimate of the Mayan population at its peak from 10 million to 20 million. On land that today barely supports 1 million, even with somewhat better seeds and farming systems than non-Mayans had in those days. And they didn't kill their trees, they didn't cut their trees down, they grew trees deliberately for building projects. The trees died after 800 AD in a drought that covered the whole area for 150 years. It's hard for even a well-established tree to survive 150 years without rain. Jared Diamond has a famous phrase in one of his critical portions of the very bad book, Catastrophe. He said, "What were the Mayans thinking when they cut the last of the pine trees at Copan?" They never cut the last pine trees at Copan. They cut trees to build more temples, and then they planted more trees. But the trees didn't disappear until the ultra-long drought. Hard to get my pages separated here. I'm submitting today that it is time, on the basis of the new archaeology, to reassess the success and failure of all the past cultures on the basis of global warmings and little ice ages. You take the Vikings, for example. They went north after sheep began to grow wool. That was about 3000 BC. Sheep originally had long, coarse hair with just a little fuzz under it. And then at 3000 BC, there was a mutation in sheep breeding. And suddenly they found a sheep whose offspring produced more and more wool and less hair. And that gave the nomads in the steppes felt to wrap around their yurts and long wool cloaks. And the Norsemen got long wool cloaks and went into Scandinavia. And they thrived during the warmings. They thrived during the Roman warming. But in the Dark Ages, they were starving. Colder, cloudier, shorter growing seasons. Couldn't grow enough hay to get their cattle through the winter. And the codfish had moved south ahead of the encroaching ice. And so they took those ships that they had developed for fishing and trading, and they raided south for 300 years. At first, they just stole. They stole silver and slaves and food. Didn't steal the horses, but they borrowed them. And then, about the year 900 or 925, the King of France said to the Vikings living in Normandy, "If you'll promise to protect the rest of France from your fellow Vikings, we'll give you Normandy." And they had conquered much of northeastern England, and northeastern England said, "We'll stop fighting you because our new global warming, our renewed global warming, is giving us enough food that you can eat, and we can live in peace." And peace and prosperity enveloped Europe, both the Vikings and the non-Vikings, until the Little Ice Age. 15th century. Columbus discovered America sailing something called a caravel. It could sail upwind as well as downwind. And caravels proceeded to swap crops and livestock worldwide and famine-proof almost everybody. America got wheat and barley and cattle and horses. The Europeans got the potato and doubled their food production in a 500-year Little Ice Age when their grain crops wouldn't ripen because it was too wet. We now have nitrogen fertilizer that's feeding 6 billion people, and the Greens refuse to use it. They want organic food. They want food not grown with nitrogen, not grown with pesticides. And they want energy not produced with either fossil fuels or nuclear. And I submit it is time for even the Greens to recognize the difference between necessity and preference. We need nitrogen fertilizer. We've got to feed 8.5 billion people in 2060 before the human numbers begin to drop off. We need the pesticides to protect that food while it's growing and while it's in storage. And we need energy, if not from fossil fuels, then from the only other source we know that works and produces no CO2. You can produce the nuclear from uranium or thorium, but you'd better produce it. Thank you very much.
Thank you, Dennis, for a truly fascinating talk. I have been fortunate enough to preview Dennis's upcoming book, in which he documents the rise and fall of civilizations based upon the climate changes that have occurred. And it's very interesting because in the media, you will see time and again where civilizations have declined and failed as a result of a cooling climate. And rather than mentioning that it's cold temperatures and the resulting declining agriculture, the media will simply refer to it as climate change caused the destruction of these civilizations. When it's not the fact that it's climate change, it's climate cooling. When we've had the warming, as Dennis documented, those have been periods during global warming when you've seen civilizations rise and flourish and be better able to feed their people. It's a fascinating topic, and thank you for allowing me to preview your book. I've taken tremendous pleasure out of reading it. Another thing that brings me tremendous pleasure is the fact that I have been able to personally, and Heartland has for many years, worked hand in hand with the European Institute for Climate and Energy. Ipcc, as it goes by its German acronym, has been kind enough to allow us to co-sponsor some of their conferences, and we're happy to have them here participating and co-sponsoring in this climate event in Katowice. For our next presentation, we are going to have Ipcc's General Secretary, Wolfgang Müller, talk about wind energy in Germany. So I turn this over to Wolfgang.
Thank you, James, for this very kind introduction. And it's really an honor to take part at the Heartland event, because for us in Germany, for Ipcc, Heartland is a role model, is an utter role model of any event dealing with science regarding to climate. Okay, so we are here in Katowice, where about 30,000 delegates and NGO people come to save the climate. And if we read the media, if you listen to the news, we get the impression that politicians and journalists try to outbid each other in catastrophic and doomsday messages. So, I mean, before we got the presentation of Craig Itzo, where actually showed, okay, rising sea levels and sinking islands and so on, they don't really take place, at least not caused by human CO2 emissions. And the interesting thing is that despite of the fact that there is basically no science, as we heard numerous times, supporting this claim, there is in Germany this obsession reducing CO2, the decarbonizing of the economy, and as we call it in German, the Energiewende, phasing out fossil fuels. So we started with the electricity sector, and okay, we look back, what do we see? About 30,000 wind turbines installed in Germany, roughly 1 million solar installations on roofs and in fields. And at the same time, the CO2 emissions didn't go down. But something happened. The electricity prices rose significantly. In US dollar cents, we pay 34 cents per kilowatt hour. And I guess many people in the United States don't even know how much they pay for electricity because it's not so much. And so while we basically invested per year roughly $30 to $35 billion in order to go green, we don't have any significant impact, and especially, obviously, nothing on the climate. So we create something which we now have to call energy poverty. Fewer and fewer people are able to really pay their electricity bills on time. They're disconnected from the grid, which is actually not a thing that happens so easily. So while actually our politicians say, no, we need more of it, I have to say this is the best example, or let's say at least a very good example of insanity. Insanity is when you do the same thing over and over again, and you just think next time there's a different outcome. So what they want to double our solar installation and probably 10 times more wind farms. But there is some autistic attitude in our political class and also among the so-called politically established experts. They ignore the fact that there are times, particularly in winter, where it's about for 2 weeks, no wind, hardly any wind, and no significant sun, not enough sunlight basically to generate electricity. So in the absence, basically, imagine this, in the absence of traditional power plants, where do you want to get the power from? At the same time, Germany is lobbying in the rest of Europe to follow our lead, basically, switching off coal-fired or whatever classic power plants. So I mean, if you are, through nature, so fortunate that you have hydropower at every corner of the country, probably that's a very easy thing. But at the same time, what many people don't even know, Germany decided to phase out nuclear. So in the next few years, we will switch off our remaining nuclear power plants. Funnily enough, this decision was taken after the tsunami. After the tsunami hit Japan, the Fukushima incident. Maybe you know about Europe and you know about Germany, tsunamis are not really a thing, that are common. And I mean, I guess it's extremely unlikely it will happen in the near future. And if there will be tsunami, I think that nuclear power will be the last issue we have to worry about. Okay, but I'm not talking about nuclear power, I just want also about the ongoing Ipcc about this. The Germans, actually, after they realized that the thing with the wars are not such a successful thing, they try now for decades, to better the world, to educate the world, to make the world green, a better place. Then when you walk here at COP, where we just were before this event, you see really thousands of people with a desire, to improve the world, to make the world a better place. I mean, as Dennis Avery said, constantly hear about sustainability. And, people have a very good heart, big heart. They want the best for the people. But as Germany shows, if you want to go green, you have to be able to afford it. I worked and did research in Asia and Africa. And the last thing, these people need, if they want to develop, okay, I'm generalizing here, I know, but for most of these people, they need access to clean and reliable energy. And trust me, cheap is not necessarily the way how you basically do the green energy in Germany. And but let me come to one aspect that is a bit overlooked. It's about why is the science so strong, supporting, I talk about the official science supporting the claim or the dogma of man-made global warming, or man-made climate change as we call it today. Okay, there's a very good example. There is Professor Dr. Henrik Svensmark from the Danish Space Research Institute. He's the father of the Svensmark effect. Svensmark effect is about the correlation about solar activity and the formation of clouds, and therefore formation of clouds influence on the climate. So he was able to test his theory in Geneva at the CERN in 2016. This was already a time when his research was not much liked anymore, because the outcome of his research is, or let's say it indicates that CO2 is not the main driver. It's the sun, God forbid. So what happened? He is basically cut off from funding. So in 2017, however, he could publish a paper together with his colleague, Professor Nir Shari from the Hebrew University in Jerusalem, basically where they proved their theory, the influence of the sun on the climate. It's a much, much stronger correlation than you will ever find for the time being, a correlation between CO2 emission and climate change. So, but the interesting part is, and the sad part is, that since 2017, Professor Svensmark is utterly cut off from funding. And his latest paper, which he published with Nir Shari, was only possible thanks to private donation he received before. Otherwise, he would have never been able to complete the research, to conduct the research to prove the theory. Yesterday I got an email from him informing me that, Wolfgang, at the last conference, where we spoke about the funding of my research, I got only negative replies. There is no way I can continue my research. And he is asking us to fund his research. We would love to. We will try to do it in our means. But isn't it ridiculous that the father of the Svensmark effect has to ask us, really one of the smallest think tanks you can imagine, to fund his research? This is beyond ridiculous. So, and if you wonder, why there is this dogma, I think I don't want to call it ignorance, it's that people can't imagine this is how so-called science works. And just before this event, I had a talk with a journalist. And then he mentioned a conversation he had just here at the COP. And he said, I just heard from a scientist, so the journalist said, the scientist who will find the true driver of the climate will win the Nobel Prize. I said, okay, this may be true, but I mean, this won't happen in the next decades. Because even if somebody will find it, that person will get a Nobel Prize probably in 20 or 30 years, at least not as long as a dogma of man-made global climate change is valid. So in this case, I just want to give the warning, don't follow the German lead. What we do is only possible because we are still able to afford it. The German Energiewende, switching green, is one of the biggest PR gimmicks we have in the latest history. So have a closer look and just don't believe what you hear, in the brochure. Bye. Okay, and in that case, I want to introduce my next, my colleague who came with me from Germany. He is Professor Dr. Horst Lüdecke. He is a physicist by training. He did research in nuclear physics and later in numerical models for chemical installations and about fluid behavior in pipelines. And he is author of numerous peer-reviewed publications in this field. After Professor Lüdecke retired from his professorship in IT at the University of Saarland, he joined EIKE and is, beside conducting his climate research and publishing in peer-reviewed journals, our EIKE science spokesperson. Horst, in this, with not much further ado, I want to give you the word. Thank you.
Thank you for the friendly introduction. My short speech will first make a resume on climate science, climate policy, CO2, alarmists, climate realists, and last but not least, the Ipcc. In the second part, I will tell you what science knows today about the influence of the changing sun on climate cycles. Policymakers, media, and churches propagate the hypothesis of man-made global warming. Man-made global warming today is a new religion, as one normally does not doubt a religion. There are no real discussions about man-made global warming. The CO2 alarmists avoid any scientific debate about causes of climate change. The religion of man-made global warming is not supposed to be questioned. Instead of this, they propagate worldwide action for establishing extremely expensive programs to reduce CO2 emissions. This means banning fossil fuels and replacing the reliable coal powered stations by windmills and solar panels. However, these renewables provide electricity only very costly and unreliably. In contrast to this, the climate realists consider the scientific basics of climate change. In addition, they compare the huge costs of CO2 mitigation against its absent benefits. Because of the deep differences between CO2 believers and climate realists, a dialogue between them is nearly impossible and seldom fruitful, if it takes place at all. Climate is not weather, but it is the more than 30-year-long average of weather. A global climate does not exist. Only climate zones from tropics to the polar regions. The climate of different parts of the Earth does even not change in the same direction. Actually, the Antarctica is cooling, and the Arctic is warming. This phenomenon, which is called seesaw, is a cycle with a period of about 60 years. This means after about 60 years, the Antarctica will warm and the Arctic will cool. The different climates in every region of our world are changing since the very beginning of the Earth and are independent from human actions, except for minor local effects as are urban heat islands. Constant climate did never exist. As a consequence, climate protection is pure nonsense. You cannot protect a thing that ever changes. It's impossible. Climate change in former times has produced far higher and far lower temperatures and stronger weather extremes than in the period of industrialization. Even the Ipcc in its reports confirms that weather extremes since the year 1950 do not exceed those of earlier times. This year can be explained because since 1950 there are very good measurements before the measurements are more sparse. Seawater gauges and satellite measurements do not detect unusual sea level rise or even its acceleration. CO2 with 0.04%, I repeat, 0.04% in the atmosphere is only a trace gas, but nevertheless essential for the life of plants, animals, and humans. Without CO2, humans would not exist at all. More CO2 in the atmosphere has increased the growth of plants and crops all over the world, we heard it already, as a beneficial effect that should be welcomed by mankind. On the other hand, global warming caused by man-made CO2 has never been proved scientifically. I repeat, because it's very important. There is no scientific proof. It is only a hypothesis. Therefore, there is no need for any policy for reducing, regulating, or taxing CO2. However, adaptation is always necessary and independent from the real causes of climate change. Adaptation exists since the beginning of humanity, and its benefits are obvious. Examples for adaptation are better dikes against floods and avoiding to settle in flood regions and so on. Now I come in my second part to the research that links climate change with solar activity. On the first slide, going back to 500 million years from present here 500 million years, we see on the upper panel the cosmic ray flux, intensity of the cosmic ray flux hitting the Earth. The cosmic ray flux consists in carbon and beryllium isotopes, which are found in tree rings and boreholes and sediments. On the lower panel, you see Earth temperatures. There's an obvious correspondence between cosmic rays and Earth temperatures, which reveals an excellent anti-correlation. Anti-correlation because you see the maxima of the cosmic ray flux correspond, also the maximum with the minima of the temperatures and vice versa, anticorrelation. You see cold ages in the years 40, 50, 450 million years ago, about 300 million years ago, and 190 million years ago, and here the warm ages at 500, 230, and 100 million year before present. In the next slide, I show you the famous Milankovitch cycles with about a period of 100,000 years, not exactly, but about. And here you see the temperatures. You see, obviously, a cycle. Here are the warm times, and here are the ice times. We are about 10,000 or 15,000 years away from the last ice age. The lower panel shows the CO2 content of the atmosphere, and you see that there's a very near correspondence, a very good correlation between the two time series, but in reality, if you have a better time resolution, we know that CO2 follows the temperature for about 800 years. That means that CO2 is the effect and temperatures is the cause, not vice versa. The explanation of this very interesting cycle is the change of the distance of the Earth from the Sun and the change in angle and the precession of the Earth axis. Excuse me. The next slide shows the so-called Ishq events, that are the researchers who detected these events, with a period of about 1,470 years. That are the red points. And you see the times of these events are several 10,000 years before present. And these Ishq events are cyclic temperature spikes, very strong spikes in very short time, in a maximum of about 10 degrees in 50 years. That is very unusual. Compare it, for instance, with the temperature rise, the latest temperature rise from 1850 until today, which is about 0.7 degrees. Here you have 10 degrees in 50 years. The causes of these events are not known. In the next slide, we see the temperature proxies from Arctic drift ice versus this already mentioned carbon and beryllium isotopes. So carbon isotopes is 14 and beryllium 10. In the lower panel, in the upper panel, we see carbon 14. Here it is, carbon 14 against ocean temperatures, and you see the very good correlation. In the lower panel, you see beryllium 14, beryllium 10. Well, it's difficult to see. Yes, see the correlation, 0.44. Not bad. Obviously, there's a very good correlation, and the researchers, Bond et al., published in Science, detected first the period as to be 1,500 years, and later this was corrected. It was not quite correct. It was a blend now. Today one knows that it's a blend of 2 cycles from 1,000 year and 2,000 years period length. We will see these 2 numbers later on. Now we see a recent scientific publication. It was from the year, the year 2016. And this shows the water discharge of the Ammer Sea. That is a sea in Bavaria, in the land Bavaria of Germany, against the total solar irradiance. And you see, you have here an excellent correlation, or as a still anti-correlation between the solar intensity and the discharge, water discharge. Now in the next slide we go back and ask when this coincidence of solar activity and climate activity was detected. And the first, that was a time when it was very cold, the so-called Little Ice Age. You see it here from about 1650 until 1720. It was the coldest part of the Little Ice Age. The Little Ice Age is longer, but it was really the coldest part. And these times, every winter, and not also winter, also in the autumn, the Baltic Sea was frozen for many meters, and the Swedish troops could cross the sea with cannons, heavy cannons, and wagons. And you see, that is the decisive, this is the point here, that this time was characterized by the completely absent sunspots. You have no sunspots at all here. The researchers who found this phenomenon, who detected this phenomenon first, were Herschel, as a German astronomer. He found that wheat prices correlated with the sunspots, which is clear. If it is very cold, you have not much wheat, and then the prices go up. And the second researchers were the couple Maunder, and after Maunder, this minimum of the sunspots here is called. The next slide shows somewhat over our own research with my colleague, Professor Weiss, was published in the peer-reviewed paper, the Open Atmospheric Science Journal, 2017. And we made the following. We looked for long time series, enough long time series, and packed them together to a new global time series. And what you see here are the spots which we used. The green spots are tree rings, time series from tree rings. The blue spots are ice cores. The red spots are stalagmites, stalagmites, and the other here, the magenta, are sediments. Here also ice core from the Antarctica. And the result is a time series over 2,000 years, which we call G7 because it consists of 7 separate time series, and each time series, each of these 7 time series has also in it many time series. And you see here the well-known shape which reveals the Roman warming period at about time 0, 0. The medieval warm period about the year 1000, and here the modern warm period, and here you see the little ice age. This is a maximum, minimum. It began here 1400 and about 50. Now we come to the reproduction of these time series. What had it to do with sun cycles? And here you see the reproduction. The red line, the black is the original time series G7. The blue line is a smooth time series, and the red line is a reconstruction with only a period, a sinus of 1,000 years, of 500 years, and 200 years, and 60 years. And all these cycles are known. These are sun cycles. 1,000 is known, about 700 is known. 200 years is very famous. It's a famous de Vries cycle, and 60 years is also known as the decadal Atlantic oscillation. And you see, we have here an excellent correlation between this red line from 0.85, the correlation with the black orange line, gray 0.65. And what is interesting, perhaps, you can make a prediction. One should always be careful with predictions, especially if predictions go in the future, you know. But here, you can argue we have an excellent correlation of the reproduction with sun cycles and the original time series. Then you can suppose that also in the future, some years, perhaps 200 years, this good correlation will persist. It's not nonsense. That is very probably, but you can't give a proper, you can't give a number for this. And you see that indeed we expect a temperature drop in the next 100 to 100 years. Here we had a short rise in the meantime, but in total the temperatures will go again down. Yeah, I like to stress that the Ipcc models until now cannot provide similar results. Impossible. And now another explanation. And in addition, here you see over 6,000 years from 2000, minus 4,000, 6,000 years, the sunspot number, the reproduced sunspot number, and here the decisive point is the huge, very strong increase of sunspot number in the last 150 years, which could explain our temperature rise. Yeah. What can we say or follow from this? That science has very good indications for the influences of the sun and on the climate, but nevertheless this IPCC does not consider it. It refuses to consider it. We see this here in this picture of was published in the IPCC report for policymakers in 2013, and here are the so-called forcings of the climate gases, and here CO2 is the strongest force. They forget to also include the A2. And that is far more. And here's the sun. It's only a little point. And CO2 is 1.78 watt per square meters. And here the sun 0.05 watt per square meters. Sincerely, you should call this ridiculous. It's really ridiculous. In the last slide now, we see the consequences of this neglection of the IPCC. The consequence is that IPCC models, which does not include the power of the sun, of the changing sun, cannot give reasonable results. Here you see the measurements that are measurements from satellites and balloons. And here you see the many, many models. Here's the mean of the models, and you see that about from 1995, the model results and the reality is strongly going in other ways. It's also with this, without, without including the sun, it is impossible to model the climate. It is impossible to model the climate and to take its CO2 instead of the sun. This is not the right way to model the climate. If it is any way possible to model the climate, you have to imagine that the climate has so many parameters. It is a chaotic system, and my personal belief is that this is never possible to manage to model the climate. You see it with the weather. You can model the weather mathematically. It's possible for about 1 or 2 weeks, and then you have the effect of chaos. That means that it's a mathematical effect. It is inevitable. Then the results, the work, for every changing in the incoming for the data. If you're changing the data a little bit, or even very, very small, then the results increase infinitely. And this is also the same with climate, it's the same effect. Also here, you have to treat chaotic behavior. It's impossible to model climate for a very long time, perhaps for 100, 200 years, but not for a long time. Thank you very much.
Well, thank you so much, Dr. Luedecke. Wolfgang tells me that that was Dr. Luedecke's first presentation in English. So it's amazing here. I will say I've been taken by European hospitality, going to Munich 2 weeks ago for a conference with the European Institute for Climate and Energy, spending a week in Prague in between, and now here in Katowice. I'm struck by how often people will apologize, whether it be in Germany, in the Czech Republic, or here in Poland. They'll speak English about 90% as well as I do, and they'll apologize for their English not being very good. And my reaction is, your English is 1,000 times better than my German or Polish, and that's after taking a year of German in high school and 2 years of Spanish. But fantastic job. Thank you so much, Dr. Luedecke. Before we get to our panel discussion that'll close out today's policy discussion, I'd like to present some evidence on science versus global warming alarmism. Oftentimes people will ask me for a summary. There's so many topics that can be addressed, whether it be the solar output, whether it be sea level rise, polar bears, you name it. There's so much involved in the global warming discussion and debate. And if I had 15 minutes to condense it and give you instruction as to what the science says and why I'm a skeptic and the scientists that I speak with, the information they would like me to convey, this is how I will do it. So, and once again, for those of you who weren't here at the beginning, I'm James Taylor. I'm Senior Fellow for Environment and Climate Policy at the Heartland Institute. All right, first of all, it's important to understand the rules of the debate, because oftentimes people will try to make it seem like you have skeptics that deny the climate ever changes, deny that global warming is occurring, deny that humans play any role, etc. And then they all say it's them versus us. First of all, we have to make sure when we have this debate that we adhere to the scientific method. The scientific method requires testing your hypotheses. You make observations, you form a theory, you form a hypothesis, but then you test it. Science is not conducted by people raising hands. Science is not done by people calling their brother, their cousin, or some editor of a science review journal and saying he believes me too or she believes me too. You look at the real world evidence and you test it. That's what we've been taught since grade school. It's ironic that in today's world, if you test an alarmist theory or prediction, and if you present real world evidence that contradicts it, you'll be called a denier. You'll be told that you're attacking science. Questioning scientific assertions is conducting science, not attacking science. When you chase out of the room skeptics, and that could be climate change, anthropogenic climate, how do I want to use the phrase, climate alarmists, but any other field in science. When you question the scientific assertions, you are conducting science that is to be celebrated, not vilified. Now, specifically, climate models that merely predict future temperatures are not evidence or proof of anything. They're merely predictions. And much of what is predicted just revolves around the subjective data or subjective theories that are programmed in. I could program a computer to play Space Invaders. It doesn't mean that Martians are landing tomorrow. It's not evidence or proof of anything. Similarly, climate models that predict future climate impacts regarding sea level rise, drought, tornadoes, etc. Again, they're not evidence or proof of anything. They're mere predictions. We test them against real-world scientific data. So, the parameters of the debate. Points of agreement. The Earth has been warming during the past century. Many people in the media, the environmental left, will make it seem like we're denying that climate change exists or the Earth warms. The vast majority of skeptics agree that the Earth has warmed during the past century. I am one of them. Also, another thing that is not in debate but is a point of agreement is that human activity is likely a factor in recent warming. Now, data indicate that solar variances in solar output have always played a large role in temperature changes and are likely playing a large role today. Solar output has increased dramatically during the past century and likely explains very much of the warming that we've experienced. But it doesn't mean that carbon dioxide is not a greenhouse gas. If you add more carbon dioxide to the atmosphere, all things being equal, you should get some warming. As a skeptic, I agree with that and suspect that some of the warming we've experienced is caused by humans. It is a factor. What really divides skeptics from alarmists, to a certain degree, how much of our recent warming is natural versus how much is human-caused. But even more importantly, the next 2 points, how much future warming is likely? Are we going to see 3-4 degrees Celsius of warming during the next century? If that were to be the case, then perhaps that would be a reason for concern. But does the evidence indicate that our warming will continue along its present path, which is much slower and not alarming at all? Another point of contention is, what will the consequences of the future warming be? If the consequences are that a warming world benefits human health and welfare and does not have devastating environmental impacts, well, then global warming is not a crisis. Oftentimes, the discussion and debate is sought to be framed in a manner that if humans cause any impact on the environment, that's horrible and should be targeted and should be kept from happening. But if warmer climates have always benefited human civilizations, for example, as Dennis Avery showed earlier, well, then again, that argues against a global warming crisis. Now, on this slide here, we see temperatures going back over varying time periods. This is from the European Science Foundation. By the way, I mentioned the scientific method. Note that every piece of data, every statistic, every peer-reviewed study I cite, I'm giving you references. These are not made-up data. These are not in dispute. Here, this is ice core samples taken from the Greenland ice sheet. The temperature reconstruction from that, this was presented by the European Science Foundation. And what we see here, take a look at the chart on the top right. What you see on the far right is temperatures today. And if you move back to the left, you see temperatures going back 10,000 years. Now, it was asserted just this week by one of the top United Nations figures here in Katowice that 20 of the 22 hottest years on record have occurred during the past 22 years. 20 of them have been the hottest on record. Well, much of that depends on what you define as, quote, on record. What they conveniently forget to tell you is that they define on record as the beginning of the 20th century. In other words, at the end of the Little Ice Age. Well, here you see the data showing that, sure, temperatures have warmed, especially if you look at the bottom chart. Temperatures have warmed since the year 1900 or so. But for most of the past 8,000 years, the vast majority of that time period, temperatures were warmer than today. It's important to understand the context of our current warming. Today's temperatures may seem warm, but it's only because we're comparing them to the Little Ice Age, which is the coldest period of the past 10,000 years. But if you look at the entirety of human civilization, what we see is that temperatures are significantly cooler than average rather than warmer than average. The next chart just backs up what I presented. These data, these charts are from the United Nations Intergovernmental Panel on Climate Change. This is their own report. This is taken from their first assessment report. Look at the second and third charts in particular. In the middle chart, what you see again at the far right, according to Ipcc, according to the United Nations, there you have present temperatures. Again, significantly cooler than temperatures of the past 8,000 to 9,000 years. The bottom chart shows temperatures of the past 1,000 years. Once again, yes, you see warming during the past 100 years, but that warming is only notable if we're comparing them to temperatures of the Little Ice Age. So if 20 of the 22 hottest years on record have occurred here in the past 22 years, it's only because you're taking a very small sample that is not illustrative of the Earth's natural climate throughout the period of human civilization. This next chart touches on a topic that Professor Luedecke mentioned, and this is a topic also at the European Institute for Climate and Energy Conference, where Dr. Svensgaard and Shaviv presented information. And this is regarding solar output. The sun has always been a primary driver of climate and temperatures on Earth. Now, these data, and this chart is taken from Geophysical Research Letters, one of the preeminent peer-reviewed science organizations, particularly on matters involving climate. And what you see essentially is a reconstruction of solar output. During the late 1600s into the early 1700s, you had very low solar output. You had a step up during the 1700s, then temperatures leveled out until about 1900 or so. Then you had a step up in temperatures through most of the 20th century. Look at that pattern. Flat and low, then a step up, flat, then a step up. Does that remind you of anything? Remember back here? Look at the pattern. This is from the United Nations itself. Look at the bottom chart. You had an ebb in solar output. You had an ebb in temperatures during the 1600s, a step up at the same time solar output increased. Then you had a plateau, and then a step up around the year 1900, again as solar output increased. What we see here is strong evidence that the sun has been and continues to be the primary driver of global temperatures. Next, it's important to look at what Ipcc has predicted. If we're going to perform science and adhere to the scientific method, let's take a look at the most central assertion from the United Nations. Going back to its first climate assessment report, the UN predicted that temperatures would rise at 0.3 degrees Celsius per decade from that point on. Now, skeptics like myself, we looked at temperature trends that had been going on in the real world. We saw approximately 0.1 degrees Celsius warming, and skeptics pretty much correlated around a 0.1 degrees Celsius per decade prediction of future warming. What's happened? Well, we've had 30 years now to look at real-world temperature records, so we can perform science and adhere to the scientific method. And what the objective data show is that temperatures have not risen 0.3 degrees Celsius or nowhere near that. Temperatures have risen less than half that, at 0.13 degrees Celsius per decade. In other words, just slightly more than skeptics predicted. Skeptics were vilified, called deniers, told that they were attacking science when they questioned the alarmist predictions of the United Nations. Now, give the United Nations, give the Ipcc, the Intergovernmental Panel on Climate Change, some credit, because they've acknowledged the error of their ways, or at least some of it, and now they're predicting merely 0.2 degrees Celsius of warming per decade. In other words, they have conceded at least half the difference between their predictions and ours. They've acknowledged that, at best, as far as they're concerned, we were equally right or equally wrong. But they're probably going to have to give more ground because, again, temperatures are rising merely 0.13 degrees Celsius per decade, not even the 0.2 that they are now settling upon. Again, comparing predictions versus real-world evidence, the skeptics were far more close to their temperature predictions than the alarmists. Why isn't the media covering that? Why does the media continue to allow skeptics to be called deniers or attacking science? It's the skeptics that have proven correct. Regarding specific climate-related events, because this is where the climate establishment attempts to pull on heartstrings. Yes, it is true that global warming will not immediately and forever eradicate hurricanes, will not chase tornadoes off the face of the earth, or droughts or floods. They have always occurred, they will still occur. Therefore, merely because a hurricane occurs, or a drought occurs, or a tornado occurs, it is not wise to say that global warming caused it. The only way you can justifiably attribute blame to global warming is if you show, through an accumulation of data, that these extreme weather events are becoming more frequent and more severe. So we do have a way to test that, again, using the scientific method. Here in this chart, we're looking at accumulated tropical cyclones. Now, on the first slide, we're looking at the frequency. At the top, you have all tropical storms. On the bottom, you have hurricanes. This is going back to 1970, so approximately 50 years of global warming. What do we see? As the Earth is warmed, we're seeing less frequent tropical storms and hurricanes. It defies common sense, it defies reason, it defies scientific evidence to claim global warming is causing tropical storms and or hurricanes. It's often said, oh, well, maybe so, but we're getting much stronger storms and the impacts are worse. Okay, here we have accumulated cyclone energy. What we see is no change. You cannot make the argument with scientific support that global warming is causing greater devastation through stronger storms. Next slide, we're taking a look at tornadoes. Now, tornadoes are pretty much confined to the United States, so this is U.S. tornado data. This is from the National Oceanic and Atmospheric Administration. Again, these are sources that are unimpeachable. What we see here is a trend in tornadoes going back several decades, and you see, depending on how you want to look at it, if you want to go back to the 1950s, for example, you see a declining trend. You can make an argument that there's no trend. You certainly can't not make an argument that there's a trend of more tornadoes as global warming occurs. Next, we have the very strong tornadoes, because often they say, well, it doesn't matter too much about the smaller hurricanes or tornadoes. It's the F3 or higher tornadoes, the ones that inflict severe damage. So here again, the National Oceanic and Atmospheric Administration has produced data. What do you see for F3 or stronger tornadoes? You certainly do not see an increase in major tornadoes and strong tornadoes. What you do see, without any doubt, is that strong tornadoes are becoming less frequent. So I'll give you your pick. You can argue that global warming is having no impact on tornadoes, or you can argue that global warming is making tornadoes less strong and less frequent. Next, anytime there's a drought, keeping in mind that droughts have always occurred throughout the Earth's history, anytime we have a drought, the blame is laid on global warming. But again, we have to look at overall data. So first of all, this is from the International Journal of Climatology, peer-reviewed publication. What the International Journal of Climatology reports is that from 1951 through 2010, the period studied, quote, for most of the conterminous United States, drought frequency appears to have decreased during the 1901 through 2014 period. So again, that's actually larger than the 1951 to 2010 period. But what the peer-reviewed study shows, droughts are becoming less frequent as temperatures warm. Similarly, USA Today reported just last year that we set a record few people know about, many people are oblivious to. What USA Today reports is that, quote, drought in the U.S. fell to a record low this week, with just 6.1% of the lower 48 states currently experiencing such dry conditions, federal officials announced Thursday. It's a shame that people don't understand that droughts, not only are they becoming less frequent and severe, they're setting records for how little drought there is. And keep in mind, when we have wildfires that do occur, as they always have, wildfires are dependent upon dry conditions, drought conditions. The argument that global warming is causing an increase in wildfires fails, just as the argument is that global warming is causing more drought. Similarly, this is from Theoretical and Applied Climatology, another prestigious peer-reviewed journal. Globally, there has been, quote, no significant trend in the areas under drought over land in the past 3 decades. Moreover, quote, Central Africa, parts of Southeast Asia, e.g. Thailand, Taiwan, Central America, Northern Australia, and parts of Eastern Europe show a wetting trend during the same time span. It's not just the United States of America. Globally, drought is on the decline as temperatures warm. Similarly, the international, this is one that we already discussed, so let's move on to the next slide. Precipitation is becoming less extreme. Oftentimes when I present to warmists the data regarding droughts, they say, oh, well then that means we're getting more frequent and severe strong rainfalls and we're getting more floods, because always we have to show that global warming is something bad. But let's take a look at the objective data. Geophysical research letters, again, peer-reviewed, prestigious publication. Scientists studied global precipitation data from 1940 to 2009. Here's what they report in geophysical research letters. Quote, we report a near zero temporal trend in global mean precipitation. Even more importantly, quote, on average, dry regions and months became wetter, and wet regions and months became drier over the period. Think about that. What that means is that when you have droughts, areas that are prone to droughts or time periods during the year that are prone to droughts, they're getting more precipitation. During time periods like the spring, when you have spring floods, you're seeing less precipitation. Overall, you see essentially no change in overall precipitation, but the frequency, duration, and patterns of precipitation mitigate against extreme weather events, droughts and floods. The report says this conclusion holds in all available databases and also holds for the time period between 1940 and 1999. If anything, these results constitute a slight decline in meteorological drought over the last 70 years. Moving on, I think the most important data and arguments are regarding human mortality. We often hear from climate alarmists that because of the United States' plans, because of President Trump pulling out of Paris, this will kill people. This will cost human lives. Well, let's look at the data and see what the data say. First of all, warmer temperatures have been proven to save lives. A study in the prestigious peer-reviewed medical journal The Lancet reports cold weather kills 20 times more people globally than hot weather. Think about that. 20 times more people die from cold weather than warm weather. And it's not a small amount, because that same study found that 7% of all human deaths globally are caused by suboptimal temperatures. As our planet gradually warms, regardless of how much is caused by human greenhouse gas emissions or natural forces, it doesn't matter because the effects are good. What it means is that those suboptimal cold temperature patterns become less frequent. The warming that occurs will save human lives. And indeed, we can back that up with real-world statistics. U.S. Centers for Disease Control statistics show 800 more people die every day in the United States in the cold months of December, January, and February than during the rest of the year. Again, the raw data, objective data, show that it's cold temperatures, cold weather, cold climate that kills people. The gradual warming that we've experienced, the warming that we can expect in the future, are going to reduce the harmful effects, the effects that kill people, regarding the colder temperatures. This is a chart that's similar to one that Dr. Idso presented. And what it shows is that there has been a tremendous greening of the Earth. I won't spend too much time on it because Dr. Idso has, but simply put, this is satellite imagery taken from NASA satellites NOAA instruments, National Oceanic and Atmospheric Administration. And what it did is it measured global foliage through a period ending from 1982, ending in 2013. It's a 30-year period. What it shows is that throughout the world, there has been by and large an increase in global foliage, and according to the study, carbon dioxide was a primary reason why we have seen more plant life. And the areas with the largest gains, as you may see, for example, look in Africa at the edge of the Sahara Desert to the south. Look in western India, areas that are bordering the arid lands of the Middle East. Look at the American Southwest. What you see is that areas that tend to be dry are the ones that have seen the greatest increase in foliage, showing that there's been more precipitation, showing that the areas of the world that are particularly susceptible to drought, to famine, have benefited under warmer temperatures. Getting back to a topic I mentioned in my introduction, the nations of the world, the United Nations, when they look to impose their collective governance, their climate totalitarianism on the United States, they vilify the United States. They vilify President Trump for not doing what they do, for embarking on a course of action that celebrates, that champions, that pursues affordable and abundant energy, that allows free markets to work. This is a course of action that does not join the Kyoto Protocol, the Paris Climate Agreement. And what is the result? The result is very simple. Since the turn of the century, U.S. emissions, if you believe global warming is a human-caused crisis, or maybe will be, or something we should be concerned about, USA emissions of carbon dioxide are down 14% this century. The rest of the world, their emissions are up 56%. If we do decide that we need to do something about carbon dioxide emissions, the answer is not the Kyoto Protocol. The answer is not the Paris Climate Agreement. The answer is not pursuing the climate agendas of China, of India, of Russia, and the rest of the United Nations. The world should be beating a path to the door of the United States, where not only are emissions going down, but freedom is being protected and sustained. Energy is affordable and abundant. The economy prospers. The human condition is lifted up without the restrictions that the United Nations seeks to impose on the little people, you and me. Backing that up, we saw the carbon dioxide emissions, but also air quality in general. What you see here, this is an image taken by Berkeley Earth using satellite imagery. They're measuring particulate matter in the atmosphere. The image is striking. Those same nations that lecture the United States about how we need to embark upon collectivist climate and energy policy, collectivist global solutions, where we have United Nations figures telling us that populism is horrible and we need to all get behind the United Nations global governance. What's happening in their countries? What you see is the dirtiest, most unhealthy air in the world is in these nations that are lecturing the United States. Look at the United States with all that green. That's the purest air that you'll see in the industrialized world, especially for a nation with the United States population. Again, if you're looking for solutions, if you believe in a climate crisis, don't go to the United States. Come to President Trump. Come ask the United States what works. The cost of pursuing the United Nations agenda means imposing expensive, rare, or not abundant energy sources on the United States. Energy costs are substantially higher when we are forced to utilize wind and solar power. The Brookings Institution, this is a left-of-center public policy organization. They published a paper called Why the Best Path to a Low-Carbon Future is Not Wind or Solar Power. The results are striking. According to the Brookings Institution, again, this is their data, this is their chart. When you replace conventional power with wind power, electricity prices rise by 50%. When you replace conventional power with solar power, electricity prices triple. What this means is that money that people otherwise would spend on education, on health care, on better housing, on better nutrition, all the things that make life more enjoyable, happier, and healthier, that money is no longer available. That's not just an economic story. That's a moral story. That's a human condition story. It's extremely important that we stand up to the climate agendas of people that would impose expensive energy on the United States, expensive energy on the rest of the world, for absolutely no good. The reason why conservatives and skeptics challenge the science is because of these economic numbers that show the costs and the impacts of the UN climate agenda. And then when we look under the hood and look at the science, as you've seen here today, the science shows that there is nothing to be gained by sentencing ourselves to this poverty and human misery. So let me conclude with the following. Always be wary of people and movements who vilify the scientific method and the people who practice it. When skeptics challenge and question and offer counter-predictions to the United Nations, we are not attacking science. We're not attacking scientists. We are conducting science. We are adhering to the scientific method. And we should also celebrate when that scientific method is applied to our own predictions. And I think most skeptics do. Climate change is the norm, not the exception. As we saw through the charts showing the history of solar variance, as Dennis Avery presented, and as well as Dr. Ludicky presented, we've seen temperature changes in the past, both warming and cooling. It's a natural part of the Earth's climate history. Keep in mind that skeptics and alarmists agree the Earth is in a warming period, and human greenhouse gas emissions have contributed to that warming. Don't let people define the debate and try to falsely paint skeptics as arguing for things that we don't stand for. Keep in mind that the Earth's climate is relatively cool by historical standards. That's a very important contextual point. And the temperatures are warming much more slowly than the UN models predict, as Dr. Ludicky presented. Finally, human health and welfare are benefiting from a warmer climate, and that ultimately is what it's about. We may have different ideas as far as how we're going to improve the human condition. We're all looking to improve the human condition. The science shows that it's the skeptics who are on the best path to that future. So with that, I conclude my presentation, and I invite the other speakers to come on up for a panel discussion that'll conclude today's program.
We only have the one working microphone. One working cord, I should say.
Okay, thank you, fellow speakers, for staying through the end after your own presentations. And of course, I've enjoyed watching yours, so I imagine it wasn't hard for the speakers to watch the remaining presentations. We have had a few questions. We've had several questions actually presented by people watching via the live stream, and I'll present some of my own. So first of all, let me ask this question. And this is for the panel as a whole. So weigh in as you see fit, and I'll hand you the microphone to do so. One of my themes is the scientific method, which requires testing your hypotheses against real-world evidence. And I think that we, just as the alarmists, need to keep in mind that it's possible we could be wrong, and we need to always be examining what the evidence shows and questioning our own projections and predictions and point of view. So let me ask, what evidence would convince you that the United Nations narrative is correct? And similarly, what evidence would, in a proper world, induce the UN to admit its narrative is wrong? Whoever would like to take the first question.
The correlation between sunspots and the Earth's temperature in the last 100 years has been about 79%. The correlation with CO2 has been about 19%. And I suspect the correlation with sunspots would be even higher if we could capture all of the factors involved in measuring the sun's activity.
Anybody else?
I hope that I have rightly understood the question. For me, the decisive number is the climate sensitivity. And there are so many publications about this number. and all the publications indicate that the climate sensitivity is decreasing in time. The first publication were about 10 years ago, and now we have the first. If you take a line through it, linear regression through the numbers of the papers of the climate sensitivity, you find that 20 years ago there are values of about 3 to 5 to 6, quite normal, and today the number is about 1 to 0.5, maximum 1, 2. It has decreased. And for my opinion, I would believe the Ipcc if the climate sensitivity would be for the majority of scientific peer-reviewed publications about 3, let me say 3, 2 or 3. Then I would believe it, otherwise not.
I'll just respond to that as well on the biological aspect of increasing CO2. And, as you asked that question, I started thinking, and I'm not sure what it would take to convince me that CO2 is a pollutant, because, there's been thousands of these studies that have looked at the benefits of CO2 on plants, and they've looked at a whole range of concentrations of CO2, from a minimal 100 part per million enrichment all the way to 2,000 parts per million. And all along that entire range, up to 2,000 parts per million, and sometimes more than that, the response is positive. You get this growth enhancement. So, and that's far beyond the range that we're ever going to see as a result of combusting fossil fuels. So, I don't see how you could ever come up with data to convince me that CO2 is a pollutant and is going to negatively impact plants. It's just not going to happen.
Okay, thank you, panelists. We have a viewer question from the live stream, and this is for Wolfgang. Wolfgang, you discussed the economic shortcomings of wind power, but what about the environmental impacts, the land use, land conservation impacts, or other environmental impacts? How does this weigh in, either as pro-wind power or an argument against wind power?
Yeah, this is an excellent question, because the development of wind farms in Germany is the example of using double standards. So we see now over the last 10 years in particular how in protected areas where we're not even allowed, an existing shed to add an extension of, let's say, 5 square feet because of for environmental reasons, they're building wind farms, where you first, of course, need major roads for these heavy trucks to bring in this super heavy equipment into the forest. So I told you, you have 30,000 wind turbines about in Germany installed, and they're basically littering the landscape. And sure, it's subjective, but the next thing is where, of course, the science there is definitely not settled, so-called infrasound, the sound you actually can't hear, which people claim is causing health issues. But one thing for sure you can see with our eyes is the birds. The birds that are really shredded by these turbines, and in particular the major birds. We don't have eagles, hardly any left. And anyway, not because of wind farms, but similar hunting birds, so the hawks. And anyway, but there are no takers for it. Okay, the bats, because of this aerodynamic situation of how the blades rotate, bats basically die because their eardrums implode or explode, and they lose orientation, and basically they fall down. And of course, in the night, the foxes come and eat it, so you don't see much of it. So you have to be really careful to see it. So there are no really scientific figures to my knowledge, but as I said, it's double standard, and we are littering our landscape. And Switzerland has very good NGOs, by the way, who they manage with enough funding for legal cases to stop almost any wind farm the moment somebody says, I want to have one.
And I'll note we can quantify that in the United States as well. Peer-reviewed studies, and I've written about them, so you can do an internet search for Taylor wind power million bird deaths. That'll pull it up. But peer-reviewed studies have showed that wind turbines kill 1.4 million birds and bats every year in the United States, and that includes many endangered and protected species. And then if you look at the American Wind Energy Association, this is the lobbying group for wind power, their own numbers show that it takes literally hundreds of square miles of wind turbines to produce as much power as a conventional coal or natural gas power plant. And these are environmental impacts that people don't want to talk about, but that's a fantastic question. And the viewer had a follow-up question, again for Wolfgang, where you talked about how wind power is not economically competitive, but can you convey that in terms of German household income and household impacts?
Okay, I'm not sure whether I answered the question entirely correct. And what was it, James? Again?
Regarding the economic impact.
Okay, yes. Yes. So, as I said, the energy mix in Germany is, of course, contains now a significant part also of wind power. And if you place these wind farms, the turbines, really there where there is wind, which is in the north, in the coast, there you can have costs which come not necessarily close, but closer to traditional generation, usually with coal, how we do it. And however, because we need the electricity, the power in the south, so we have to get the power, the electricity down south, so we need the power lines, which we don't have yet. So we are rebuilding the grid. We are basically having a double infrastructure, because the wind farms are there where is no industry, or at least not enough. And the industry is there in the south. So in the past, one would have just, and we still do this, ship coal down or up the river Rhine and burn it. Or we have these other lignite coal plants somewhere in North Rhine-Westphalia, where the economic powerhouse is of Germany. So I repeat, I mean, we have to have this transmission issue. The grid was not designed for this. We're still rebuilding it. And as I said, we spent about 35 billion, and just to go green on electricity, and we only have, let's say, roughly 25%, for good measure, maybe 28% going green, which is a mix which already contains solar, wind, and actually quite a significant part of biomass. Nobody actually likes to talk about that one. And so you can say, I mean, to be fair, the real cost of wind energy, that's not the only issue. It's about reconstructing the grid in order to accommodate the wind energy. And we have this administered prices, guaranteed feed-in tariffs, where every wind farmer has a right, entitlement basically, that once you have whatever your unit of electricity produce, the grid has to take it, has to buy it. And you basically have to scale down traditional generation. So the coal plants and sit there idle. Of course, they have to still there to back up, because we don't have wind constantly.
If I could just add a comment, James, I've personally visited a new chemical plant in Cleveland, Tennessee, that is costing $2 billion. 6,000 construction workers put it up, 650 permanent jobs. It's for a German company which can get fracked natural gas for 1/3 the cost of buying natural gas imported from Vladimir Putin in Germany. And Germany's investment capital is flowing not to wind and solar, but to places with real low energy costs.
And I will also address the viewer's question in terms of the experience in the United States. I've documented, and again, you can find this if you do an internet search for it, that in states with renewable power mandates, 29 states have renewable power mandates right now. In those states, electricity prices have risen 50% faster than in states without the renewable power mandates. And of course, that stands to reason when you look at the data that I presented from even the left of center Brookings Institution, documenting that wind and solar power are more expensive than conventional power. So if you force people to use it, prices will increase, in this case 50% faster. Similarly, in Arizona this year, there was a ballot initiative that would have imposed a 50% renewable power mandate on Arizona electricity production. And again, in an analysis that I wrote and published that you can find on the internet and that was referenced in the Wall Street Journal, what you look at is that if that 50% renewable power mandate was put into place, the average household would pay more than $2,000 every year in higher electricity prices. You're getting the same amount of electricity, but you have to pay $2,000 plus more for it. And that's money that comes out of other important household budgetary items. Now, if you can just throw away $2,000 plus and not miss it, well then, by all means, if you don't worry about birds getting killed or land getting used up for inefficient energy, go ahead and do it. But there's a reason why Arizona voters voted against it overwhelmingly, and that's one of them. Question for Dr. Ridso. Regarding plant growth and in particular crops, I've seen assertions that, okay, maybe you're getting more mass from plants when you have higher carbon dioxide concentrations in the atmosphere, but there is a declining amount of nutrition in these crops when you have higher CO2 levels, so that negates, and indeed more than negates, the gains in terms of plant mass. So would you have anything to say about that?
Yeah, I'd be happy to address that. This is one of those scare stories again that's been making the rounds about every 5 to 10 years. It circles back, and we've looked a lot into that. The first point to make is that not all studies show that. So, some do, some don't. In fact, and then recently there was a review paper that was published. You can go on our website, look in our subject. Well, actually, it's co2science.org website. And go to my subject index under letter N for nutrition. And the very first paper that you see archived there under a whole bunch of papers that have been archived deals with a review study of 57 different papers that looked at this issue of nutrition and looked at specifically vegetables, both root, stem, leafy, and fruit vegetables. And they found pretty much mixed results. They found that looking at a whole slew of nutritional related minerals and characteristics of the plants, they found that out of a total of, 26 or so, they found that 10 of them were positive, had positive increases in those minerals or nutritional substances. 9 experienced no change, and only 7 were negative. So on the whole, it balanced out as having a positive effect on nutrition, that is rising CO2 levels. But in those small cases where CO2 might reduce nutrition by 5-10%, you can obviously overcome that by taking a few more bites of the material that you're trying to eat. And if you're in Africa, that's something you don't worry too much about. You need that extra food. But you can also overcome it through various other management approaches. You can find a cultivar. Different cultivars of different crops will respond differently, and some will have higher protein concentrations than others. You can also optimize the nutrition level by changing or maximizing your fertilizer when you put it on, how much. You can adjust the harvest time. That will also impact nutrition, and also you can have environmental stress. You can add salinity to the soil, and that will obviously induce stress and build out antioxidants and things like that. So there's a number of management approaches that any single one of them can overcome if there is, in some small cases, an actual nutrition decline. So it's really a non-problem, something that we really don't need to worry about. Did you want to say something?
Okay, thank you, Dr. Ridso. Another question from our live streaming audience, noting that we've discussed solar variation. And the question is the United Nations Intergovernmental Panel on Climate Change, are they ignoring or minimizing the effects of variance in solar output? Are they doing it to suppress that information? Are they just missing it? How and why is the United Nations selling short the impact of solar variance on global climate? And I know that Dr. Luedecke might want to take this one first.
Yeah, they don't suppress it. They say only we don't know the mechanism, and we don't know, if we don't know the mechanism, we ignore it. They argue that the total solar irradiance is the solar constant is really constant. If you consider only this mechanism, you can have a good argument. But if you have all indications about, I have told, it was a very short overview. All these, there are no proofs, but there are indications. They show that there must be an indirect mechanism, amplification of the influence of the sun. And Wolfgang already told this. There are some researchers, famous researchers, Hendrik Svensmark and Nir Sharif, who have shown that such a mechanism exists, and that he also theoretically works. They have made I don't know exactly, I believe it's only 1 year old, a new paper in which they explain exactly, theoretically, how it works. And Svensmark had made the experiments, and that fits very well together. That is not enough. There should be another researchers following this way and confirm it. That's the only problem in the moment. But it would be very easy for the Ipcc to take the already known, for instance, the isotopes, the changement of the solar isotopes, beryllium-10 and carbon-14, and to put it in their models. They don't do this. And I cannot say exactly why, but I have a hint, perhaps. The Professor Marotzke, he is a modeler in Germany. He was sometimes asked, I don't know exactly from who it was, why do you don't consider the solar influence in your models? And he gave only a very short answer. It's not necessary. It's nonsense. It's nonsense. I don't do this. CO2 is the strongest, makes the strongest impact. That's not necessary. They don't discuss about this. We think over, my colleagues and I, we think over to take perhaps sometimes some of the models, they are free. The models are, in principle, they are free to get them. And they are, in the moment, also, it's simple models. And to make a guess, to put the solar input in these models and show what happens. But we have no time. We have other things to do in the moment, other projects. But in some time that will be done, but it will not be done from the mainstream, because every researcher who is paid in the mainstream will not do this. It's too dangerous. He will be pushed out. That's a problem.
I think it's worth remembering that when Galileo asserted that the sun was the center of the universe instead of the earth, the Catholic Church put him under house arrest for the rest of his life. And I think Dr. Svensmark, who's been testing his theory successfully since at least 2001, and the recent CERN study was the most sophisticated test of it, and it came through with flying colors. And basically, it said, CERN said the Little Ice Age was much cloudier than we had thought, and the modern pollutants from burning fossil fuels are much less important than have been asserted. And basically, they endorsed the 1,500-year climate cycle, the Dansgaard-Oeschger impacts. And Svensmark is being treated much like Galileo, and I'm so sorry to watch it happen.
And we have a follow-up question on that point, noting how the United Nations credits all sorts of positive feedback mechanisms that amplify the initial modest warming from carbon dioxide. And the question is, why won't the United Nations acknowledge that same impact regarding solar output? And I'll take this one myself. At the European Institute for Climate and Energy's conference, which we were happy to participate in, we had Dr. Svensmark and Dr. Shaviv that gave in-depth presentations, and that's going to be available online, I'm told, by the end of the month. So I hope that you will look for those presentations. And they've presented in the past at Heartland Institute conferences, so you can find presentations of theirs on our website as well. But the one that they presented this past month is with the newest up-to-date data. But for those who just want kind of a base level explanation, it's simply this. The United Nations will go back and they will infer the amount of energy variance from the sun, and that's all that they will infer or apply in terms of impact on climate. Now, increases in carbon dioxide, it's a pretty precise scientific formula that you can double the amount of carbon dioxide in the Earth's atmosphere since the beginning of the Industrial Revolution, and you'll get approximately 1.1 degrees Celsius of warming. The United Nations gets around this and makes alarmist predictions because they say that little bit of warming caused by changed carbon dioxide levels is going to have all sorts of other impacts that make it worse. Now, regarding the solar variance, what Dr. Shaviv and Dr. Svensmark have shown is the influence of solar output on cosmic rays. So essentially, the solar system, including the Earth and its atmosphere, are constantly bombarded by cosmic rays, which are particles emitted from nova and supernova throughout the universe. When these cosmic rays reach the Earth's atmosphere, they form ions and condensation nuclei around which water vapor can turn into clouds. And clouds have a cooling effect on the Earth's temperature. So what Dr. Svensmark and Shaviv have shown is that when solar output is strong, when it's higher than normal, not only does it directly warm the Earth with its higher energy output, but it creates a stronger solar wind that shields the Earth and the solar system from cosmic rays. And what this does is it prevents the ions and the condensation nuclei from allowing clouds to form. So not only do you have the direct heating from higher solar output, but more solar output means fewer clouds, which tend to be cooling mechanisms. So without that cooling mechanism, the solar output impact on temperatures is amplified still further. And that's what the UN climate models fail to acknowledge. And yet the CERN experiments that Dennis Avery discussed have proven time and again that this is an actual impact that scientists should be paying attention to. And skeptics do, and the United Nations doesn't, because the UN finds that finding to be inconvenient to its alarmist climate narrative. Somewhat along those lines, Dennis, you and Fred Singer wrote a landmark book that I discussed and you discussed about unstoppable global warming every 1,500 years. And I know that wasn't the central topic of your presentation, but in that book you documented the solar cycles that have governed climate and temperature change historically. Do you have information for what we can expect regarding solar cycles for the remainder of the century? And perhaps Dr. Ludicky might have some information too.
Well, predictions are not my strong suit. I will note that the current warming of the Earth is not as great as it was during the medieval warming or the Roman warming or the Holocene warming. That doesn't tell us how great the warming just ahead will be. But if we take the 30-year phases of the Pacific Decadal Oscillation and assume that it began to shift from warming to non-warming at about the year 2000, that would imply no additional warming until about 2030. Now, at that point, all other things being equal, we might say, oh, well, the alarmist will then start being right. But as Dr. Ludicky pointed out in his graph, the projection at the moment, and this is from astrophysicists who have re-examined the solar sunspot minimums. We used to think those were events, not cycles. And they went back and looked carefully at the counts through the centuries, figuring that maybe some of the minimums that didn't cause famines got missed. And they did find that to be true, and they're now saying it's a 200-year cycle. The last sunspot minimum cycle, the Dalton, ended in 1830. That would imply that sometime shortly after 2030, we're going to, at least that soon, we'll likely see another drop in temperatures from today that will be 60 years of cooling, taking us from 2000 to 2100 with no warming at all, and maybe an overall cooling trend. That's a long way from mind-blowing warming.
Yeah, perhaps only a short remark to this. As I know, the literature of the sun, the special, not climate, but sun, all authors confirm our findings that it will be in the next time cooling from the sun. And insofar, I agree completely with you. But one has to consider that there is also another elephant in the room, the next ice time. We can see that perhaps in the next 500 or 1,000 or at the maximum 3,000 years, and the Milankovitch cycles continue, what is very, very probable. There's no reason because the Milankovitch cycles should end or stop in our times. Then we will get a new ice time, and a new ice time means that the glaciers from Sweden and from Sweden come until northern Germany, and all these countries, Siberia, Sweden, Canada, you can't settle there. Even with modern methods, it's finished. You have to go under the earth. And that will really a challenge for the humanity, not a little bit CO2 today.
And you present a great point, because for viewers that saw the temperature history, they were in my slides as well as Dr. Ludicki's. If you look back at the temperature history of the Earth going back several 100,000 years, indeed the past 3 million years, for the past 3 million years we've been in an ice age. We still are. And the ice age is characterized by approximately 100 to 150,000 years of glaciations, advancing ice sheets, and then very brief periods between those glaciations. They vary in length but average about 10,000 years. And if you remember from the charts that I showed, our present warm period has been in existence for about 10,000 years. Oftentimes I'm asked, what if I'm wrong? And we can discuss that certainly, but what if carbon dioxide emissions, the modest warming impact they have, are what is saving us from the next full ice age glaciation? An ice age glaciation would have, exponentially, it's hard to quantify how much more severe an impact on humanity, human health and welfare, the environment, than would even the worst global warming predictions. And I'll also note that some of the speakers at the European Institute for Climate and Energy Conference in Munich a couple weeks ago, their conclusions looking at the cycles were that we can expect to have the impacts of solar cycles would have a cooling impact through the remainder of the century. And of course, if carbon dioxide emissions mitigate that somewhat, maybe we'll get an idea for how strong or how sensitive the climate is to carbon dioxide emissions. But that'll be interesting to watch. One other thing that at the Munich conference a couple weeks ago, the absolute star of the two-day conference was a gentleman who presented on the climate history of the Sahara Desert. And if you're watching this, you must watch that when it is posted by Wolfgang and his institute. And I'm hoping, I know this wasn't your presentation, Wolfgang, but you're familiar with it like I am, I hope. Maybe you could summarize for our viewers what was presented scientifically regarding climate change and the impacts on the Sahara Desert.
Yes, I mean, it was definitely, yes, James, a stellar presentation. And Professor Kröpeling from the University of Cologne, who for decades is doing empirical research in the Sahara Desert. And, I mean, he must almost live there. So what he does, for decades he goes there and finds places which look a little bit like from Indiana Jones. And, for example, finding oasis where there is a lake, and in this lake you find a crocodile, which a few thousand years ago, when the climate change, was cut off from the rest of the waterways. Anyway, but this is just the surrounding. So he is with his whole equipment bringing there, drilling in this lake, finding, getting the sediments, and so he has a perfect climate archive. And basically the bottom line is, the Sahara Desert was green. Yes, there was a time when Sahara was just a normal place where there was a lot of waterways, and there are many artifacts left which prove, this was basically, by then standards, a normal area populated, which was just hit by climate change. And anyway, I mean, we saw by the other presentations, so it doesn't correlate at all with the CO2 changes in the atmosphere, and I mean, he talked for a bit over an hour, and so it's tricky now to sum it up. But I mean, the one thing was certain, okay, there is constant change going on. And James, am I missing one point? There's okay, you bring up the one point there. Okay, say it yourself.
Thank you, Wolfgang, and thank you for putting on your climate conference every year, where we have scientists that previously nobody knew about, and findings that may have been reported in some sphere that weren't applied to the climate change discussion, which should be. And the biggest takeaway for me was that the presenter showed that it was approximately 6,000 to 8,000 years ago when the Sahara Desert became its greenest. And if you recall from the Greenland Ice Core project from the European Science Foundation, the data I showed, that is when temperatures were the warmest. It was the end of the last ice age glaciation and the warming of temperatures above what exists today that turned the Sahara Desert green. And after that climate optimum, as it's called, at the warmest period of the past 8,000 years, have temperatures with fits and starts, sometimes trends up, trends down, but overall that declining trend, that is what has caused the disappearance of the grasslands and the savannas of the Sahara Desert. It's cooling temperatures that cause the desertification of the Sahara. And the presenter also noted that in recent decades, with the warming we've experienced, that the desert is receding, which is pretty true to what the climate history shows. And it's not just the Sahara Desert. Deserts around the world will also, as the presenter showed, will also benefit from warmer temperatures. And while many factors will affect this, the most important is that when temperatures warm, you have more evaporation from the oceans. The winds then carry them over the lands, including the deserts, and you have more precipitation. And that more than outweighs the warming temperatures in terms of the drought factor. And again, it's empirical evidence. We can have these theories. I can concoct a theory. The United Nations can concoct a theory. And it may sound fantastic. And you can back it up with all sorts of whiz-bang scientific jargon and theories. But ultimately, you have to test the theories. And you test it with evidence. And the evidence and the data show that the Sahara Desert and deserts as a whole have always benefited from warming temperatures, not cooling temperatures. Here is a question that is presented by one of our viewers in the live stream. And I don't know if this one has an answer, but I'd like you guys to give it a crack. The question is, what is the optimal temperature range and optimal levels for atmospheric carbon dioxide? Is there such a thing? What is it?
Well, in terms of carbon dioxide, it depends what your definition of optimal is. If it's increased productivity, increased water use efficiency, you're going to see that on up again, up to 2,000 parts per million. So, it's safe to say that that the more CO2 up through that range is more beneficial to the plants. Someone else want to speak about temperature?
Yeah, the question is not easy to answer. If you look at the ice ages in the last 1.5 million years, the Milankovitch cycles, you see that the very cold times had about 85 or 90% of the whole time. And the warm times have only the rest. That means 10% or 15%. That is very interesting. If you see the warming is very quick. Also the end of an ice time is very quick, and then it slowly goes down. And you have a long time where it is cold. Yeah, what is the optimal temperature for human beings and for animals? There's no doubt that warm times are optimal. The warmer, the better. I don't know any drawbacks of warming, because the warming is more on the poles, not on the equator. More on the poles, there's warming. That means that the differences, the temperature differences between poles and equatorial zones are becoming smaller, and that means weather extremes don't depend on absolute temperatures of the atmosphere, but on differences of the temperatures. That means that if it is warmer, then the weather extremes decrease, not increase. And that is also the finding of the Ipcc. We have, in the moment, it is warmer than in the 18th century or so, and we have less extremes. It's only necessary to think in the flooding. Look at the gauges. You find it in Germany, and every river you find the gauges in stone, and you see that the biggest flooders were in the 17th, 18th century, not in the 20th century, or the 19th century. That means, it's my opinion, the optimal temperature is warm times, warmer than today, a little bit warmer than today, for my opinion.
Talking about food production, the UN doesn't like to talk about modifying where we grow crops. And we started out with the Corn Belt being in Illinois. And Illinois is still the heart of the Corn Belt for America. But now we're using short season varieties to grow corn all the way up into Ontario and into the Manitoban northern areas. And looking back at the year 1300, when the medieval warming was ending, they were growing corn all the way north to the Laurentian Shield in Canada, and I assume they were growing corn, or could have been growing corn, further west. The Indians were growing it, and those were varieties that had originated in central Mexico. So there's a whole lot of ways that are available for human ingenuity to increase food production if food is short.
And Dennis, you bring up a fantastic point, because where we have, for example, records of wine grapes being cultivated in England where it's far too cold to do so today, where we have records of settlements in Greenland in areas that are still buried under cold and snow and ice, that haven't become warm enough yet to reach those temperatures. It was in those periods 1,000 years ago that human populations increased dramatically, and it was at the end of that warming that human population shrunk. It wasn't the climate change that caused the problems at the beginning of the Little Ice Age, because a climate change to warmer temperatures enabled people to settle in Greenland, enabled populations to expand throughout the world. And one other note regarding that question in terms of optimal carbon dioxide levels and temperatures, you'll note that there's been a cleansing of the language regarding certain historical time periods. The time period from approximately 5,000 to 8,000 years ago, when temperatures were at their warmest since the end of the last ice age glaciation, and temperatures were 2 to 3 degrees Celsius warmer than today. That used to be known, before this became a political issue, as the Holocene climate optimum. Optimum meaning the best possible conditions. It was when temperatures were at their warmest that human civilization was first able to develop, and when scientists were able to see the benefits of warmer temperatures. But now with the politics involved, you don't hear it referred to as a Holocene climate optimum as much anymore, whereas that used to be the universal term. Before we conclude, I'm just wondering if any of the panelists have anything they would like to add, any questions for each other. And afterwards, I guess I have one more question online. All right, so keep them coming. But anything that you'd like to comment on that I haven't hit upon that you would like to? There we go.
There's one interesting part, which is hard to believe if you believe actually in science. And we last week in the federal parliament, let's say, caused by politicians in the federal parliament, by the parties, there was like an expert hearing. So every party in the federal parliament could nominate an expert. And among these experts there was also the already mentioned Professor Nir Shavi from Hebrew University, Jerusalem. And so he gave a presentation basically of what we heard today. Here's a correlation of solar activity and cloud cover, and therefore effect on the climate. So he gave beforehand, he handed in the paper, so because the time was so brief that he could not give his entire presentation. Nevertheless, so another expert, German professor from another institution, his only comment to Nir Shavi's presentation was, "That's rubbish." He didn't mention any reason why he thinks this is supposed to be rubbish. And I rest my case. This is the curiosity, basically, of the so-called established scientist, the politically appointed scientist on the climate issue.
I'll just make a quick comment, and that is just to thank all those who participated in this latest NIPSI report. A lot of hours and sacrifice went into putting it together, so thank you to all of those who were authors, contributors, reviewers, editors, and so forth. Appreciate your efforts, and just a plea that you'll come and read the report, that you'll pass it on to your friends, your neighbors. We need to get this report out there. People need to understand what we've talked upon here today is just scratching the surface of what's in those NIPSI reports, full of valuable information. So please just go read it and send it on.
Okay, we have another question, and this one, it's fitting enough because we are in Katowice, Poland, and the person points out that Al Gore had warned that in some areas of Poland, children are regularly taken underground into deep mines to gain respite from the polluted air. Is there any comment on how that prediction or that warning has played out? And of course, Al Gore has many canaries in the coal mine, he claims, for global warming. But what are we experiencing in terms of not just warming temperatures, but air quality as a whole that is being blamed on fossil fuels?
One can almost say this is a Al Gore classic. But before I say what you actually mentioned, but for the people who follow us in live stream and can't see the weather here, we don't have the Al Gore effect yet, so it's not yet snowing. Okay, but on a serious note, which is funny that Al Gore mentions now basically pollution. And this is actually one of these things of this, let's call it sloppy language, to say it politely, because the whole time, as I talk about CO2 emissions and so on, and carbon dioxide, a pollutant, and of course us claimed as deniers, climate skeptics, then we are painted in the corner or pushed into the corner, and we don't care about the environment. So when somebody talks about the air quality, It's of course something completely different, but for the general public, they mess it up. I mean, they really don't distinguish. So being now here in Katowice, I mean, you have to keep in mind that the Soviet system was here, the system of not choice, but by the oppressive Soviet system, which actually prevented any kind of normal economic activity. So only after the fall of the Soviet Empire, Poland was allowed really to become an independent country. Since then, actually, Poland could develop and could move away from utterly dirty industrial production and energy production. So the quality we experience here, for anybody who ever traveled to the east, I mean the Eastern Bloc in winter in the 1980s, the air quality is very good. It is not very good by Western European standards, but it's actually really fairly good. We have winter here. People heat their homes a lot with coal. I mean, they have coal-fired ovens in their homes because gas here is significantly more expensive than the United States, manifold times more expensive. So the heating material of choice here is actually coal, and they have local coal, which is very cheap. So long story, yes, the air could be better, but I have to say, when I was in East Germany in the early 90s, in winter there, at night you walk up because your throat hurt because from the sulfur acid in the air. Anyway, we are far away from this here. So, I mean, I think it's fairly okay. I mean, it's not perfect. As I said, the Swiss Alps, I prefer the air there. But, I mean, this is utter rubbish to say. I mean, here that somebody has to go underground to be protected from the bad air.
I would also point out on Al Gore's behalf that most of our improvement in air and water quality in the United States occurred before he became vice president.
And I'll further note that it's economic prosperity that is so important to countries as well as people being able to afford the technologies that allow for clean air. China has a great deal of coal power, and their air is extremely dirty. It's unhealthy. In the United States, we have had a good deal of coal power without those health effects because of our prosperity, we have more environmental equipment attached to our coal power plants such that the pollution is only a fraction of what would exist in China and India. And the market-friendly policies, when you encourage individual economic freedom, when you allow societies to prosper, then, I mean, choosing between eating and having somewhat cleaner air, people are going to choose to eat. But when you encourage a healthy economy, then people will have the ability to demand and put into place these technologies. And we see that the chart I showed with the satellite data from Berkeley Earth showing how clean the air is in the United States, despite the fact that our domestic national product, our gross national product domestically is greater than any other country in the world. We have all that economic activity, and yet we have the clean air. And in Poland, it's interesting because under President Trump, we're seeing encouragement of the export of American natural resources, including fossil fuels and including natural gas that will supplant and replace natural gas that currently comes from Russia. So you have the environmental activists that are seeking to block what they deem as a dirty fossil fuel, and yet here is something that sending it to Poland, where we produce the natural gas in a much more environmentally friendly manner than Russia, is something that's going to help our economy, help the Polish economy, help our environment, help the Polish environment. So there are many ways that encouraging markets and encouraging the path of the United States as opposed to the UN path is the way to go for economics and the environment. Let me wrap up by thanking everybody who has watched this presentation. I know we started very early in the United States. It was 2 p.m. here in Katowice, Poland, and it was 8 a.m. in New York and Washington, D.C. For those of you who would like to see more of the science, because believe me, you're not going to see any of the science at the United Nations gathering just down the road, go to climatechangereconsidered.org. And there you will find the reports from the Non-Governmental International Panel on Climate Change. You'll find the newest one that NIPSI has produced, Climate Change Reconsidered 2 Fossil Fuels. Much of what we discussed is in there. And you can also go to heartland.org, for more general information on energy, environment, and climate issues. So thank you for our panelists. Thank you for everybody who watched. And make sure that you're always questioning the science. You're not attacking science, you're performing science. Thank you very much.